So I'm gonna be working. I think I'm gonna work on the site again, and not again. Continue to work on the site, and I'm gonna study Ethereum speedrun. I think I'm gonna try to do this Ethereum speedrun. There's another site here that I found that I thought was pretty cool, which is a free site to train React, and I think I'm gonna do that. And I think I managed to do what I had to do until next Sunday, which is to be able to allow people to mint an NFT on the Polygon network, the testnet, and on the Rinkby testnet. And it was a lot harder than I thought it would be. So I'm very happy that I managed to do that. And the reason why it was so hard is because it's pretty easy to connect someone with the MetaMask through vanilla JavaScript. You pretty much just capture the window object, and the window object, if the MetaMask is connected, is going to have an Ethereum property. And then you use that Ethereum property to connect the user. But the problem with that is that if you have a React application, then if you connect the user in one component, it may not be the case that the address that you're going to get or the information that you're going to get on the other components is going to stay the same. And it might change on different renders. And that's why it was very difficult to try to figure out a way to make this work. And you have to use the context. And I tried a bunch of different ways. I followed a bunch of different tutorials, and a lot of them didn't work or work, but it wasn't allowing me to do the stuff that I wanted to do. And the one that I ended up using was this React. Let me see if use React Web3 React Core. This library here seems to work, and what they do under the hood is pretty much use context hook from React, and it's very complicated, the source code, and I think I might study that as well on stream. And besides that, there is also I think Web3 model or something like that allows you to connect as well, which is pretty much a library that has a component. If you got into any websites that require authentication with MetaMask or any other wallet, you've probably seen this, which is a pop-up that shows up and allows you to embed different wallets into the site. And I think it works pretty much the same way or a similar way using context for React applications. But I think, yeah, and I also try with use Morales as well, which is a similar thing. But that one, I think the problem I was having is that they require a library that you need some C++ stuff installed on the computer, and I was having a lot of problems because I'm using Windows. So I opened Ubuntu and I tried that. I tried it in Ubuntu, and in Ubuntu it seems to work. But in Windows it wasn't working because of the dependency, and I tried a bunch of different ways to solve that, but it didn't work. So I decided to scratch that one and go with this one. And if I couldn't do it with this one, then I would have to create the context myself, which would take a lot more time. So I'm very happy that this one worked. It seems to work so far, but I still have to change a lot of stuff here. So yeah, I need to figure out a way to get the information from the token ID after they mint the NFT, because the other way that I was getting doesn't work, because now I create a different contract abstraction, and I think I'm gonna show it, the difference. And before it was a lot easier to do this because they provided the contract kit from Silo, which is a similar library, but that one works really well, and I didn't have any issues, so it was really easy to connect the wallet. And I didn't realize that it would be a lot harder to change networks because of all of this stuff. But it was a very good learning experience. I think I'm gonna put some music, because I had to review all these concepts and study React context and the use graph and other hooks. So that was really good. And pretty much the difference is that before I was getting the contract, I was creating the contract abstraction by having these two files here in the hooks. And on this file, I was using the other use contract file, this one, and this one was creating the contracts. Maybe I can open up actually and compare side by side. I think that's better. Yeah. So this was the other project, CMD, code. Put this one here. Yeah, so this one was like this, and this works fine because I'm using this connect kit here from use contract kit, which is a tool that comes from the Silo network, and it works well. I wonder if I could use this one. I didn't try to use this one for connecting into the polygon, but it might work, maybe. So maybe what I should do is try that before. But I also think it's better to try the other way, because that way I'm not relying on this one. So with this one, the thing is, so I have these two files here, and they each call the use contract, which is this file with the address and the API, and that's all the information you need to create a contract abstraction. Then you access this get connect, make the kit, and then you make a Web3 contract using the Web3 library. And it works fine when you're using on the other pages. But the problem is, if you're not gonna use that, you need the signer, which is the address here, and you also need the context. You need the contract address, and yeah, in order to get the account and to get the signer, you need the context, because of the stuff that I was talking about before, where you need to have a reference for the account on the whole application. You can't just get the connection in one page, because then you're going to lose on the other components. Or you're going to do something that is called pop drilling, which is in React, everything starts from the top component, so which is it comes from the library app.js, is the highest level component. Then from the app, you go into the other components, and you can pass data from the one lower level component into a higher level one, but it's a lot harder to do. And it can cause something that is prop drilling, which is eventually these components, these things that you're passing as props to other components, start to add up, and then it becomes really messy, confusing to use or to code. So in order to avoid that, you should use this thing called React hook, React context, which is use context hook from React, that allows you to pass information from one of the lower level components into anywhere else in the application. And that's pretty much the problem I was having here, because I'm using the navigation here, and the navigation is the component that is going to allow user to connect the wallet. But then I wasn't being able to pass the connection from the navigation into these other components, because they are on the same level. So I can't go back to the app and pass this information. So I had to decide, either I was going to move the navigation into the app component and then pass as props to these other components, but I didn't like that much, because I wanted to separate the logic from the navigation and the app, because later on I think I'm going to change the navigation a lot, so it's cleaner in my mind if I do it like this, because then I can add a bunch of different pages here, and it's not gonna get all messy with the code from the navigation. And that's pretty much why it took me a long time to figure out, because then you have to go in this navigation component, you have to use the use Web3 React, and this is going to allow you to keep the context of the account information from the user. So when it connects here, the code under the hood creates a context for the account and all the other information, and then you can use this information in anywhere else in the application that you want by just calling the same context, the same hook, and then accessing this stuff. But then the problem is you can't really do it like this because of the thing with the signer. So if I was trying to import to do the same way that I was doing here, where I just use this use market contract on other pages to create the contract abstraction, but it didn't work because it wasn't allowing me to export this if it isn't React hook, and also because I need to get the context here. That's the difference. And the other one I didn't need because I was using this kit here, but now I need to put the context, so it wasn't working. And yeah, and the other difference is the signer here, that I need the signer, and before I didn't need it. So in order to get the signer, you also need the context, and that's the problem. So to deal with that, I found this video from this guy. Maybe I should show as well, because this video helped me a lot, but I don't remember really well. Maybe if I put... Where is it? It pretty much, this video here. This video helped me a lot. So it pretty much explains the source code and the stuff that I was talking about. And the other issue is that you can't really log out the user. So when you disconnect the user, what's actually happening is you're just removing the event listeners that you get when the user connects. And the only way for them to truly disconnect is if they go into their MetaMask wallet and disconnect manually. And the reason for that is because you can't have access to their wallet through the website. There's no way to handle that, at least for now. So yeah. So from his code, I was able to get this, to do this library and account here, which comes from the context. As I'm calling this on other pages, I'm passing the context here to get all this information and create the contract abstraction. But then the problem is that I can't really call this contract here to call the function because of the context. So I can't use meter contract on other pages because it's gonna mess up the context. And that's the problem with doing things like this, because now I have to repeat myself because I'm gonna be importing the get contract and all these addresses in all the other pages that I'm gonna use the contract abstraction, instead of having the logic on these files here and then just calling the shoe files. It doesn't work because it doesn't allow me to call these React hooks inside of this function here, because this function is not a React component or some other error that was giving me. So the only way that I found to work was to call this get contract directly and then pass the information from this page where I access the context. And so if the user is not signed, is another problem as well, because then obviously it's gonna give me an error that I can't get the signer. It's signer from undefined or something like that. I can't get signer from undefined because the library is undefined because the user didn't log in. So in order to prevent that, I have to put this, if the account is not connected, then I alert and click put please connect wallet. And this seems to work fine. But now the only problem I have is when I call this function, the way that I was doing here before was, because the contract is different, the contract abstraction is different, I was also calling methods on this and then send from and then owner address. I had to remove the from because it wasn't working. And this way it works now, but then the transaction object is different. So it doesn't give me this information here, which doesn't allow me to get the token ID. So I have to see if I can get... I think the only way that I can think about right now is getting directly from the contract after they mint to retrieve from the contract the token ID of the last NFT they minted. So the last NFT is always gonna have a higher count. So I'm thinking about calling a function from the contract and then passing in the filtering for the highest count and for the user address. And that way I can get the latest NFT that they minted without getting mixed with other NFTs from other people. If two people mint at the same time, then it can give me an error. And I need this token ID to list on the market here to create this function. But from what I checked on the Etherscan, it seems like it's working. I think it seems like it minted the NFTs, it just doesn't display because it didn't list on the markets. I don't know exactly where it is, but I remember seeing the transactions here. And there were a couple of transactions made. Yeah, whatever. So now that's one of the issues that I have, is figuring out this, how I'm gonna get the token ID after the transaction here, after they mint to list on the market. And I have to change the other pages. This one I also had to change because of the contract abstractions. So another error that I was getting is that I couldn't declare the contracts on the use effect, because then it would say that the contracts are not defined when I'm calling in this function. So in order to change that, I declared them here using lat, and then it worked. And the reason why I had to move them inside of the use effect is because I want the contracts to, the abstraction to be created as the page loads. So it has to be inside of the use effect. And I think I couldn't make inside of this function because of the context. It was giving me a mistake there. I couldn't make this because I had to check if the context exists, if the account exists, and I couldn't do that inside of this function. So I had to move it here. And now it works, but then this is also bad because it's alerting as the app loads for the first time, it sends this alert, and I don't want that. So I'm gonna have to return something different here, I think. And then it also was giving me a warning that this is gonna change each time I load the page. It's not gonna save the stuff from the contracts here, because I was putting this in the dependencies of the use effect. And then it was telling me to use this use graph and the current property of the use graph in order to save the contract here. And the difference is, I think the use graph keeps a reference for the components, and the context, the current property of the use graph can change each time. So you declare like this here in order to create a reference, and here you just make the current property equal to this. And it seems like it's working, but it might give me some problems later as well. I didn't test this, I think. But the main part, I got it, which is to allow people to mint the NFT. And the biggest thing for me that is, to be honest, I don't really care about the... I think I said this a bunch of times. I don't really care about the NFTs, and to me the marketplace itself is... I just want to get it done as fast as possible, all this stuff that is related to the marketplace. And then it hit me when we were doing the exercise on... Not the exercise, the meeting on Sunday. the first meeting, they talked about each person had to create a banner or something with explaining what they're gonna do and then share on Twitter, something like that. And as I was doing that, it hit me that I actually can connect the two projects that I wanted to do. For some reason, I was thinking about them separately. I think it's because it's two different things, but then I realized that why not just put one project inside of the other one? And then if I can't do the hard project, at least I have the easiest one, which is the marketplace, the NFT marketplace. But what I truly want to work in is the stuff of the data analysis of the other project that I was doing. And that's what excites me the most. So I just want to get to that point as fast as possible. And this stuff is kind of annoying to me because I don't really care about it that much. So my idea now is to do... I don't think I'm going to do a bunch of contracts, smart contracts for the marketplace. I think I'm just going to keep it simple. Just these two contracts, one for minting the NFT and the other for creating the marketplace. And what I'm gonna do is put a section on the site, on the navbar, for data analysis, and I'm gonna create accounts. I'm gonna try to create backend on Django or Flask. And then I'm gonna allow people to create profiles, and then that's the part that excites me the most, which is gonna be searching for how to get the data from the blockchain, from the Polygon networks, and from a bunch of different protocols. So I can make a bunch of data analysis and speculate or try to see how, study the flow of money and how this impacts social structures. And that's what I really want to do. So I think now that I got over this thing, I'm gonna study try to do this Ethereum speedrun. And do the challenges as well, which is the stuff that I'm interested in. But I also have to finish this thing here, so I'm not really sure. Because ideally by Sunday I have all the functionality of this site working, at least for like the same as it was before for the Silo network, but for Polygon and other Ethereum networks. So I have everything working, and then maybe even the backend and integrating with the graph, because I don't know how hard that's gonna be as well. And I just want to get that stuff done as fast as possible, so I can start working on modifying the navbar and adding a bunch of different pages. I think is gonna be a lot of work as well, and I'm not sure how hard it's gonna be. But I also feel like I have to study. What I want to do is study this stuff. I want to do this Ethernaut here as well, which seems really interesting to me. Which is pretty much I saw from the Ethereum speedrun thing. I think Austin mentioned this, which is pretty much a more advanced crypto zombie stuff. It's for understanding solidity and more lower level stuff, which is what I want to understand, what I'm really curious about. Both these and reading the yellow paper from Ethereum, and also going back to those articles on OpenZeppelin to try to understand the assembly code of the thing. And what I really want to understand is how I want to see everything. I want to understand how everything that is possible to do with the transactions, and what kind of information I can have access to with these different blockchains, and how how Polygon is connected with the Ethereum as well. Because I understand the concept of layer 2, which is pretty much a blockchain that is built on top of Ethereum, and that's why it allows for lower gas fees and more transactions. It bundles a bunch of different transactions at once, and then only sends to Ethereum after it has a lot of transactions, as far as I understand, but I don't understand really that really well, and I want to understand that more. and understand what kind of information I can get from that, so I can think about which tools I'm gonna build. I wanna see if it's possible to build something that allows me to see patterns of pump and dump, for example, to track different wallets and to see how frequently they are buying and selling certain assets, and then training machine learning models on that in order to create an abstraction of I want to try to see if I can approximate a multifractal pattern from these transactions in order to capture the essence of the market economy on social structures. Well, that's the long-term vision, I think. But I think this is a good start. In order to do that, I'm probably gonna have to learn all this stuff, this lower level stuff on Solidity. So I think I'm gonna do that, because that's what I'm interested. Now that I got over with the stuff that I had to do for this weekend, I'm gonna do this today, and I'm probably gonna finish or try to advance as much as possible by Sunday on tomorrow and the next days. But now I think I'm much more excited to work on this stuff here. Oh, and Austin said that in order to do this one is more advanced. In order to do this one, is better to start with this Ethereum speedrun. And that's why I'm gonna do the Ethereum speedrun today, I think. And the other thing that I wanna do as well is go into I already took a brief look at the source code of this library here. And it's really interesting, and I think I'm gonna spend some time studying this as well. Because it's really complex, the way that they do everything. And it's interesting to understand in case I need it in the future, obviously. Ideally, I would like to be able to, even though if I'm not gonna code this, because it can be a waste of time, it's probably a waste of time, because other people are being paid to create these libraries and save everyone time. But ideally, I would like to have the skill to build this from scratch in case I need it. Even though I'm probably not gonna do it because I don't have time. But to understand how the library works in the lower level stuff, in the source code. Scaffold. Yeah, this is but this is not the Ethereum speedrun. It's the whole project. And this one is I got from the GitHub, from the free code camp tutorial. I was also studying this one and trying to integrate, but it wasn't working. I also spent a bunch of time trying to integrate this one, but also didn't work. And this is from Amorelis tutorial as well, NFT. I think I'm gonna delete these ones because I'm not gonna use them anymore. Except from the scaffold, because I might use for the Ethereum speedrun. And I think I have a folder here with that, yeah, speedrun Ethereum. So let me start this and see. Maybe I can change some things before I move on into starting the Ethereum speedrun. Oh, I think I was gonna change this alert here first, so it loads the component instead. This component here. And maybe I should put this on a component as well, now that I think about it, because I'm also using this on another page. on the Explore page. And my only concern is that these bugs or it doesn't do what I think it's gonna do. But then in that case, I think I'm just gonna return return, and then not show anything. I think that's fine, too. Or maybe I can put here on the console log, on the error. Instead of console logging, I can put the alert there. But then I think it's also gonna fire when I load the page initially, which is not what I want. Okay, so apparently it didn't show any message. And also I have to fix this CSS, but this is just a minor thing. I'm gonna change the whole navbar, I think. I'm definitely gonna change the whole navbar, and I'm gonna make drop downs here. I think it's gonna be a lot better to add more stuff. Yeah, okay, so now it gives me the alert. Oh, it's weird because I didn't save this. Okay, so now, yeah, nice. Oh, but this is still not showing the NFTs, but I think I'm filtering through the market contracts, yeah. So because I just minted them and I didn't put on the marketplace, it doesn't show up there. So maybe what I could do is change the Explore page to use this stuff as well. To be honest, I like doing this more off-stream because then I can use the two screens and it's a lot more space. And it's quite annoying to have to split the screen here. So I think that's one reason to do this Turing speedrun instead of working on this now. And I think I'm probably gonna delete these files unless I can think about a way to, because ideally I would have the logic for the get contract on here. That way I don't have to import the contract address and the API each time I'm gonna use this. Each time I'm gonna create a contract abstraction. And I also had to change these pages here, which is the contracts here, because otherwise the imports were not working. So I had to transform them on JS. Oh yeah, that's another thing that I have to do. I have to change the deploy script so that it creates these files like this, and I also have to change it so that it creates multiple different files on here, on the contracts, multiple different folders, depending on the network that I'm gonna deploy. So maybe that's what I can do right now. Yeah, so I think I'm gonna do that. I'm gonna change the Explore and then see if I can change the deploy script as well. I think I was waiting to change the deploy script later because the priority is figuring out how to list on the marketplace. Also had to change the functions because I'm using a different contract for the market now. And that's another thing I'm gonna have to do. Just to change the buttons on the cards. So this get listing, so the other functions work. Yeah, but initially, like I said, I was thinking about spending a lot of time trying to make the market more complex. But I think that's not what I'm going to spend most of my time on. Because after that, after Sunday, I realized that it's probably a lot better to just leave the NFT marketplace as simple as possible and then spend a bunch of time trying to focus on the other stuff, which is the data analysis. And I think eventually what I'm going to do is try to slowly transition the marketplace from being an NFT marketplace to being a data analysis tool for blockchain, I think. So maybe try to integrate MEV and yeah, that kind of stuff I think is really a lot more interesting. Trying to find these patterns and see if I can design an algorithm or something like that to spot these patterns on chain. And also try to understand human behavior from that. Like put metrics on stuff. For now I'm gonna close that. Yeah, so I took a picture so I don't have to mint every time. There's this one here. And this is the thing that I'm getting through the transaction now, which doesn't contain any token ID. And I remember I did a function to get, maybe it was this one. I'm also gonna remove this because now the contracts are different. But I think I can use this function here, maybe. Hopefully. Because if not, then I'm gonna probably have to do everything again, find a different way to create the contracts and all of this stuff. Which is really annoying. On the Explore page. So let me see. This is gonna return promise all. So maybe I should do a wait, get NFTs, pass the contract, and then I should filter and yeah, I think it's. I don't remember how to sort the array on JavaScript, but it should be fairly easy. I think it's just sort. In Python we sort it and then you pass the array, I think. And I think the token ID is the index. Yes, I'm gonna have to sort the objects actually. Maybe I should call that first. Just see. And then I just reject the transaction because I don't want to mint NFT. I don't want to spend the fake money that I have on the wallet, because you can only get a limited amount by some time there. Oh, this is giving me a warning here, I think. Oh, it's because I'm using a different contract. I forgot about that. I changed the... I don't remember if this one has... I got this one from the Free Code Camp NFT marketplace tutorial. Yeah, so I'm gonna have to change that, everything on that, because the mapping is also different. Yeah, listing. I don't think there's a function to get all the NFTs. So maybe I'll have to code it. But I think I'll think about this later, probably do this stuff off stream. Oh. It was probably on this. I should also remove all the console logs that I have there. Yeah, this function is giving me an error. I was also having a hard time deploying through Polygon, but for some reason it works the way that it is now, but I couldn't deploy to Polygon. That's another thing that I'm gonna have to see. And the thing is because of the RPC, and I think it wasn't just me, as from what I've researched, a lot of people were having issues as well. I think it's a problem with the testnet, the RPCs on the testnet. Yeah, I was gonna remove this once. I can't really, or maybe I can, actually. Remove this. And this one. Oh, and every time that I reload the page, it clears the wallet because of the stuff that I was talking about earlier with the logging. That the library has some problems. It doesn't really log in, so in order to do that, and this I got from the video from the guy as well, that helped me a lot, which is this window load, you clear the local storage. So every time I reload, I have to reconnect the wallet again. But because the wallet is technically connected, what's actually happening is just the library is subscribing to the events of the wallet. It's not really disconnecting the wallet, it's just unsubscribing from the events when you reload. Or maybe I should reload. Yeah, but then same thing. There's this one.
That's all they talk about. The ocean. And the sunset.
Or maybe I have to call it from
How fucking wonderful it is.
the owner address.
Melt.
I'm not sure if I can do this. Because I don't have my wallet stored. And it wouldn't be best, obviously. No, from this, sure. So this is my wallet address, I think. So I am actually calling the thing. So I don't think that's the error, and this is probably the address of the contract. I think I'm gonna search for this. Let me clean the history. And these cell phones are really annoying. I don't want to have to code this on the contract because then every time we're gonna interact with the contract is... Or maybe it doesn't matter because you're actually not modifying the blockchain. But I think ideally you have to, if you can, you have to put this stuff outside. It's better to put this stuff outside. To have as little functions as possible in the contract. And the thing is that the variable is private, and I think it has to be this way. Not it has to be, but it's probably better. I should probably also remove this total supply and stuff in the future. The other thing that I don't know really well as well is when I have something working and people are using, how can I update the contracts without losing all the data from the other ones? I don't think I've seen anyone talking about this, because usually what people say is just deploy the contract again, but then you lose all the information from the other ones. So maybe you have to code things in a way that you are storing every address from each iteration that you do, and then you just every time you redeploy you just create more functions, but that doesn't seem really scalable. Because then the application would be more and more complex every time you redeploy the contract. But maybe you can create a function actually that gets the loops through the addresses and gets the same information from all of them. Yeah, but then if you change the functions in the contract, it's gonna be different. Unless they all have the same functions and then the new ones only have the function has the same name but they do different things, or has more functions than the other ones. Yeah, but then it would fail because whenever you're calling a new function, the other ones wouldn't have that function, the older ones, so it would break the app. Or the one I have should rely on using Etherscan's API. Doesn't seem really good to me. So maybe on the different one. Yeah, I think I'm gonna see if there's a difference. But I don't think I changed the smart contracts from the Silo network to this one, the NFT smart contract. I just changed the marketplace smart contract. I think it's the same thing. Yeah, same shit. So it must be the way that I'm calling, because now it's different. I'm not using the methods and I'm using a different contract abstraction. But and also this perform actions here that I'm not using, because this is from the Silo network. I was also looking at their source code for these components, these contract Silo components. That might be interesting to study as well. I'm just using a wait here and then calling. Total supply. Okay. I remember seeing, it must be here somewhere, the contract stuff. Get contract kit. It's very complex. I'm trying to understand the difference between the contract that I'm using now and the contract kit and the contract that I was using on this one, to see if there's anything on the source code that is related to that total supply stuff, or if it's just because it must be the libraries that I'm using to create the contract abstraction, because the other one allows me to get the total supply and this one doesn't allow, so I have to figure out how to use this one to get the total supply. I think I'm gonna just search the documentation if I can find anything here. Ethers project contracts. But I think the function has to be from one of the libraries of the contract. It's probably a function that I'm inheriting from the other functions on the smart contract. It can't be from the library itself, so the difference is the way that I'm calling it, probably. The reason why I'm not being able to get them in the first one. Oh, because this one I'm using Web3 and this one I'm using Ethers, probably. So maybe if I search Web3 contracts, maybe the difference is not around the kit. Yeah, so I have to study the documentation, I think. But maybe I think I will leave this stuff for later, actually. I think I won't work on this stuff here on stream. Because I already got done what I needed to get done until Sunday. So I think I'm gonna stop here. Pretty much next things I'm gonna do is figure out how to get this, how to call this function, and then get the token ID so I can mint the NFT, so I can list the NFT on the market. Or maybe actually I can change the, I think this one is gonna be easy to change. Put this on the right, and then yeah, I'll be right back. I'm just gonna copy this stuff from this one to this one because it's pretty much the same thing for the contracts here. I'll be right back. Let me see. This one here. Also gotta change the imports. Oh, this one is gonna be. Oh no, I think it's the same thing. Yeah. The same thing. Should just this one. Okay, now I think it's the same. It should be the same now. The only difference between this page and this one is that this one filters the NFTs based on the address of the wallet that is connected. So it only shows the wallets from the user. And this one shows all the wallets. Oh, I forgot to copy the context here. And true. I wonder if I can erase this React as well that I'm not using. Okay. Nice. Now it seems, yeah. I think it's working. So we're just gonna stop this for now. Oh, yeah, I'm gonna leave it like this and deploy everything. Okay. Then I'm gonna close this and I'm gonna I think I'm gonna do this stuff first. Which is these React exercises, and then after that I'm gonna watch the video, this video here from Austin, and then I'm gonna do the Ethereum speedrun. I'm not sure how long I will go on the speedrun. I might just skip stuff. I just want to see if I understand the concepts and everything that he's talking about there. Because what I'm really curious about is this one, which seems to be more advanced stuff. And I might read the Open Zeppelin article that I was reading the other day as well, about the assembly level stuff. I pretty much, the things that I'm most curious about is how to get information from the blockchain, what kind of information I can get, and the connection between different protocols and layer 2 and layer 1. I think that's the stuff that I'm most interested about. Complete the create div element function such that it creates a React element that represents a div with the text hello world. Alright, this one, how can I do that? I think you just create elements. But then how do I do it? Creates elements div. Don't remember really well how to do this. Inner text. Let's see if this works. Yeah. The previous exercise was teaching how to do the create element stuff, but I forgot. I'm just gonna look at the solution. Maybe this is React create element div. And do I have to import? Like this. Probably not gonna work. This is really cool as well that they have a timer for the solution, so we don't look right away and try stuff. The children parameter. I think this part is correct. In order to change the text to either do this or this. And from what I remember, inner text is more secure. And this adds the test to the element. But to create the element, I don't remember really well. And maybe this is wrong as well because it's on React and not the vanilla JavaScript. I don't think it's like that. I think I tried that, it didn't work. Maybe I should just search. Oh, yeah, but I think I tried this. It didn't work. Maybe they want me to import. Create elements. React is not defined. Maybe now is the child stuff. HTML. Let me see what methods I can use here. Oh, it doesn't show me. That makes sense, because otherwise you would just look at it. So child, maybe? Yeah, I have no idea. Maybe if I use .append or push, something like that. I'm gonna try push because I don't think append works. Yeah. Push. Okay, it doesn't work. Nice. Hmm. And this stuff not that interesting to me. Maybe I will start the speed run. Maybe they probably will talk about components, but it's gonna be later down the line. So it's pretty much the same thing. I forgot how to add class. Class name, class list. Or something like that. Title. It's probably not gonna work. Have to put it inside of the thing. So I guess the object in the middle is the properties of the element. So I guess the more advanced ones are paid. I think I'm gonna start the other thing then. And first I'm gonna watch this video. Actually, not this one. I already have opened here. Nice. The thing is, I wonder if I can do them on stream. I think it's not a problem, but because they are locked, so not sure. Maybe I'll do the free ones. I'll follow the free ones and then I think I've seen a YouTube channel talk about this, creating multi-sig wallet. I'll do the free ones and then I'll start this one. Maybe read the article again. Or read stuff about the Polygon network. About how the EVM works as well, the Polygon network.
as part of Solidity. And how do we learn them? Well, we just copy and paste them in there, right? Boom, address, default address. Okay, let's not do that. We don't want to start it out with 0. Let's put in our front end address, right? Let's see, here we go. Grab this dude's address, paste it in right there, no quotes around it, boom. Yarn deploy. Now what should happen is our contract should notice this new address showing up and there it is, default address. Okay, let's not call it that. Let's call it owner, right? And this is arbitrary. I could just call this Austin or front end or something, right? It doesn't mean like owner is not a special name. It's just an arbitrary name we add in here. So let me go ahead and deploy that and that should turn to owner. So now we're deploying our smart contract and it has some arbitrary owner we're tracking. And we're learning that by going through Solidity by example, learning these new Solidity topics by just pasting them into our contract and tinkering around. So one of the first things that you're going to do once you get in here and start building your Solidity is write a require statement. So I guess let's real quick look at this. What is this contract so far? This is the default contract you get with Scaffold ETH. It's kind of like an attester. You have some string purpose, and then you have some function that lets you, well, what am I doing here? Lets you update that purpose. And what the heck? There's a console log in there. Wait. Console log. Okay, hold on. What is that doing? So let's go over here and try to set the purpose. I'm going to grab some funds from this faucet, and I'm going to say hello world, and I'm going to post that. And where did that console log go? Oh, wow, look at that. A console log, thanks to Hardhat. Right there in our Hardhat node, we see some feedback about what's going on there. Okay, so now I am going to, let's just like quickly prototype this app and then look at like what this takes to deploy, just because we're so limited on time. So your front end, usually you're going to build out a front end. A lot of times the front end gets pretty close to being, let's say we're building a counter and we're creating an increment function or something like that. You could easily use this debug for that. Eventually for your users, you want to have a nice, pretty UI, but this lets you prototype that interaction. Let's just say we are going to go with a purpose and we're going to make an attestation app, right? So we have this purpose and we let people set the purpose. What we want to do here is we want to set up some kind of rule. Let's say at first, maybe we would require that the message.sender is the owner, but then it's like locked up to only us can access that. So let's make it more decentralized. Let's make it more like a vending machine, right? Let's make this a payable function. Okay, and let's require that the message.value is greater than or equal to 0.001 ether or something like that. And if it doesn't work out, we'll say not enough. Wow, great spelling. Not E-N-O. There we go. Not enough. My cat's trying to get in here. Sorry, Kitty. I'm live, Kitty. I can't do it, Kitty. You guys just hang on out there. All right, here we go. We're going to deploy this new contract, and we're going to test this require statement. And you'll notice that the set purpose changes. Look at that. Now we have this transaction value here. So now when I say hello world, if I don't send any value along, it's going to throw an error saying not enough, right? So what I need to do is point. Can you guys hear the cat meowing? Then I add that in, and I hit send. That time I paid for it, right? And something really interesting happens here. The contract earns some value. Now there's $2 locked up in that contract. So we might need another function that's maybe called withdraw, right? Withdraw. And what's that going to do? I don't know. It's probably not going to be payable, but what are we going to require? We're going to require the message.sender needs to be the owner, right? And if it's not, we'll say not the owner. And if everything is right, I want to send all the money from this contract. And what do you do to send ETH? You go to Solidity by example, and you click sending Ether. You know, it might be nice if it was just a send or a transfer, but actually the syntax is a little wild for sending ETH because we need to control the gas in case we're sending it off to a multi-sig that needs to execute a little code. But we're going to do message.sender.call, and we're going to send value. What's the value going to be? It's going to be the this address this dot balance, right? Something like this. Let's see if this compiles. Yeah, I don't think we even need to use this. Let's see. Let's throw it at the wall and see if it sticks. Please work. All right, there we go. Okay, so now we have a new app. The app requires that you pay to set a purpose, and our owner can withdraw, right? Let's make sure all of that works real quick. I'll just say hello. I'll send in some funds, and then let's do a bad guy first. Bad guy. How do you create a bad guy? You create an incognito window. You go to localhost. It's going to generate you a different burner wallet in the top right. Notice these two are different. You grab some funds from the faucet, and you try to withdraw. See, the withdraw button is right there, and it should say not the owner. Get out of here, you jabroni. Okay, now we come back over here as the owner, and we withdraw. Ta-da! The money comes out of the contract and goes to us. Okay, so we've almost got this thing ready for production. I'm going to pull out the console logs. What do we want to do right before we deploy? Dang, let's add some new financial mechanism. What are we going to do? Okay, let's make a UNT256 price, right? Public. Let's make it public so it shows up. Everything's public on a public blockchain. Let's make a price and let's set it to this 0.01 ether, right? Something like that. Let's put that up here. Again, we're rapidly prototyping these ideas. We're trying things and seeing what sticks. Now we're going to say got to be equal than greater than equal to price. Does it deploy? Let's see. I want to make sure that price is okay. Here's the mechanism I want to add here. I want to say each time someone sets the purpose, the price is going to go up 1%, right? 100 divided by price times 100. Now we can't just do 0.01, right? There's no decimals, no floating points. You got to do this, and let's even like make sure we get the order of operations right. Okay, I like this. I feel like our price is going to go up 1% with each purchase. Deploys first try. Let's go real.
I'm gonna grab something to eat while I watch this, and then after I finish watching this, I'm gonna start this one. Maybe I will just walk through the challenges and see if there's anything that I think is interesting, and not actually do them. Just check them out and then start this one. I'm more interested in this one. This one I remember I did already, but I didn't complete it because I didn't have the fake money on the wallet. But it's really simple, so I don't think I'm gonna do this. And this one, I don't think I read this one. So maybe I'm gonna read this one and then, yeah, I'll be right back. I actually think I'm gonna remove the camera as well. Yeah. So, and turn off the light. So maybe I'll turn on the camera later, but yeah. All right, I'm back.
Real quick, before we ship this to a public network, let's go real quick and just test this out and make sure that if I put in that price and I send it, the price goes up 1%. Then the next time I try to post something, there we go. That price is going up on a price curve. We've got our app ready to go. Now, of course, you would build out a lot more front end here. You would spend some time making this thing super pretty, but for the sake of getting this out to a public network, I'm going to assume that we've basically got that part built and your app works and looks the way you want. Let's real quick look at the front end just to show that like there's this back end, the smart contract that's getting deployed. But over here in the front end, you have this really nice kind of setup where you can select what network you're going to, and then you have this nice home.jsx where you can edit your stuff at app home. There's examples of like what the current purpose is, what your balance is. There's a lot of stuff here that shows you kind of some of the gotchas. And if I zoom in on something like format ether, right? When you're going to display a big number, you need to do format ether, right? Let's see if there's a parse ether in here. No, there isn't. When you're going the other direction, when you've got like 0.01 and you need to put that to a big number, you've got to do ethers.utils.parse ether. Just something that you'll get used to as you build these things out. They're all here with examples for you so you can quickly kind of iterate. The other thing I want to show off, something that you've got built into your front end, is ETH hooks. So we started out just with components and hooks built into Scaffold ETH, and we realized not everybody's going to use Scaffold ETH, but these hooks and these components are super powerful. So we carved those out. We cleaned them up. Shout out to Shravan and Bliss and Mark and a bunch of other people that have helped with this. But the ETH hooks package and the ETH components package are going to be these nice, clean. Go look at ETH hooks on NPM. The code is nice and clean. It's TypeScript. He's writing tests for it, just like all this stuff that Austin doesn't do. Shravan is doing much better. But check this out. You've got use balance, use block number, all these hooks that will help you kind of get the state set up in your app. And basically, what do? You set up your ethers context where you've got signer provider account. You can grab your local balance or get, I don't know what that status is. You can get some information. The use balance, like it'll just load your state up with the balance. Here's different ways to use that use balance, right? So all these hooks that you're going to need to make your front end work are all here and ready to go for you. And if you don't use Scaffold ETH, you should still look at ETH hooks and check that out and use that in your app. If you're like a hardcore TypeScript person and you are allergic to Scaffold ETH, these components are still available for you. Okay, let's pretend like we've built our contract, we've built our app, we've kind of built those two things kind of in symphony and parallel, where we're kind of learning how the Solidity works as we poke at it. And we're finding what works and what doesn't work. And maybe this array of structs didn't feel quite right, but we tinkered with it for a little bit and we got it right. Now we're ready to deploy to a public testnet. So it's super easy. Basically, what you do is you, when we're deploying to Hardhat, when we're doing this yarn deploy, it's just using a Hardhat. It's using a local blockchain. It's using this, like we get some free accounts with those. But when we deploy to a public network, we won't have those free accounts. And this is all in the docs and it's easy to get to, but what I'm going to do is yarn generate. That's going to create an account for me, basically create a local mnemonic and give me an address that I can fund. And that will be my deployer account. So if I do a yarn account, that's going to show me a nice QR code for that. And since Polygon is a big sponsor, I'm going to try YOLOing this to Polygon. I think we may have some RPCs wrong, but homie Jason is in the chat and he's got me some better RPCs. So if this falls over, we'll just adjust a few things. So I'm going to use my Punk wallet, punkwallet.io, built with Scaffold ETH, super forkable, wallet connect up front. I'm going to hit scan there and I'm going to scan this QR code and I'm going to send $10 of Polygon. Is $10 of Polygon enough to deploy a contract? I bet it is. All right, now I'm going to assume that address has Polygon on it. And I want to make sure, is it called Polygon or Matic in the constants? I need to make sure I deploy to the right network. It is called Polygon. Okay, and there is an RPC. So we're good there. I think maybe I was looking at this wrong, Jason. Sorry, I sounded the alarm on the RPC. Here we go. We're gonna try to deploy to Polygon. We'll see what happens. So I'm gonna do a yarn deploy -- network Polygon. Right? I've tested all locally. I've played around. It looks good. It works well. How do I deploy it to a public network? Super easy. Yarn deploy and then that network. Here we go. Oh no, the JSON is definitely not liking that. Okay, let's try an alchemy key here. Right here, I think. Let's try this. Hopefully, I'm not leaking keys. No, invalid JSON response received unauthorized. Okay, should we try Mumbai? Let's try deploying to Mumbai. Oh, I'm in the wrong config. You're right, Jason, live, good call. I need to be over here. Okay, so there's two different configs. There's the front end and the back end. The back end is Hardhat. You've got constants there. The front end is React. I was over in the React constants. I need to be in the Hardhat constants. All right, let's look. Is it called Polygon here? Let's look here to see if it is called. Yeah, it is. Okay. Oh yeah, there we go. We've got a weird URL in there. I don't even know how that got in there, but let's pull that out. I don't know who put that there, but there we go. Now let's, oh wait, is that Polygon Mumbai? I think that's Mumbai. Here we go. Yeah, I got it. Wrong one. Here we go. You got to get, I don't know why that was using Morales. Okay, yarn account. Nope, that's not what I want. I want yarn deploy to Polygon. Please work third try. Come on now. Deploying contract. Oh man, what now? Intrinsic. Oh, I don't have enough money. Really? What's the gas? 1, 2, 3. 1, 2, 3. That should not be that much. Let's check. Maybe we don't have enough. Ooh, what if we're looking for Polygon here? Do we have a Polygon balance? Got to have some Polygon. Let's see. Come on, where is it? There. Oh, it says I have 0. Okay, so maybe the burner wallet didn't send. Let's try that one more time. Make sure I'm on the right network. It is on Polygon. It's in Polygon 2D24. Strange. I'm not sure. Let me try one more time. We might have to just go to another network. I would hate to do that, but I think. Let's see. Let me grab. Let's see. Let's just send some Poly. Let's make sure. D24 Matic. Let's send some Matic. Here we go. This address. Send 10. That should be enough. And it should be gone, right? Like 5 seconds later. I'm assuming that account now has Matic on it. Let's try this deploy in 5 seconds. Let this finish. Come on. Kind of pushing the, maybe. Maybe. There we go. Okay, so maybe my Punk wallet doesn't have the right RPC for Polygon either. Okay, now we've deployed our contract live. We've got 7 minutes left. So like I said, we've got the front end and the back end, right? We basically deployed our contract to Polygon. That's our back end. Now our front end needs to adjust. It needs to point to that new network. So over in the front end, I think we've got that right now. I can go to app. Here's the change. Here's the one change I'm going to make in the front end. I'm going to change this right here to Polygon. Now, assuming all your RPCs are right, sorry I had to dance around those. It should be just a couple things you need to change. Now our app is pointed at Polygon. Now we're using that. Oh no, it's not. Oh yeah, it's connecting. We just don't have. Okay, and now at this point is a good time to bring in your MetaMask too, right? You can connect your MetaMask. Hopefully this starts to show a balance. There we go. Okay, so the RPC is working. We're just waiting for this contract to deploy. Is really the case here. I wonder if I didn't do enough gas here. Is one going to even be enough anymore on Polygon? Maybe this has changed and it's gotten more expensive. Let's like jack this up to 5 and try again. Let's see. I don't know. Increase the gas. Yes, please go get it. Okay. Okay, there we go. Our contract is deployed. Okay, cool. So now our app is up on Polygon, and there is the contract. So what I'm gonna do is start a yarn build. I need to get that going because it's gonna take a second. It's gonna build our static site and let us deploy it. But let's go play around with it. Like I said, now that you're on a public network, you can connect that MetaMask, quit messing around with burner wallets. Oh, Polygon gas, Jason says we probably needed 3.2 or something. Yeah, it looks like it increased it. So we got it deployed. Okay, so our contract is now out on Polygon. Our app is pointed at Polygon. It's building. We're close to being able to just deploy that thing and let someone, but let's just tinker around with it real quick and make sure this works. So Austin Griffith wants to say, hello world. Which version of hard hat? I could find that out. Let's see. Hard hat dash version maybe. MPX hard hat dash version. We try to keep up with hard. Yeah, 6.14.14 may not be the latest, but we try to keep up with them. Okay, so Austin Griffith is going to say hello world. He's going to spend 0.0001 Polygon. It's going to prompt me. All right, make sure we're on Polygon-matic. There we go. Now that transaction should get processed in a few seconds. We should see the new purpose get updated, and we should see the price go up 1%. Now our app is working. We're tinkering with it. There we go. The price went up again, right? And I can say hello again. This is what it's all about, is being able to rapidly prototype, throw these ideas out there and try things, see how they feel, see how other people use them, get other folks to use these. And by the way, going back to that Punk wallet, maybe my Punk wallet wants to say something. Right? I'm gonna log out of there. I'm gonna go back to my Punk wallet on Polygon. It failed us earlier. I'm not sure why that happened. I'm gonna hit scan. Look at this. I'm wallet connecting in with a Punk wallet, a browser-based wallet. I just logged in as punk.austingriffith, and let's see. Oh, he's got his $30. I don't know why that didn't work. Okay, this is Punk AF, and what are we gonna spend? We're gonna spend this much money, and when I hit send here, it should prompt me over here. Yep. There's that transaction, and I hit okay. We just wallet connected in with a browser-based wallet and using scaffold ETH. So using a very forkable wallet, you can fork that wallet and have a nice web wallet and connect to all your apps. Last thing, here we go. Yarn surge. Ooh, what are we calling this? Dash domain. I'm gonna call it. It's kind of like an attester, right? I'm gonna say attestor. Ooh, I like that. That's good. Attestor. Okay. .surge.sh. And here we go. Now we're deploying our app live. So we've got our contract app. Now we've got a front end going on. And now anyone in the world can go to attestor.surge.sh and they can put in a purpose here. Please don't put in any dirties because it's going to be up on my screen for the next 3 minutes. Don't do it. But here is the link. I'm going to paste it into chat. And now anyone can go to attestor.surge and they can connect their wallet and they can talk to that smart contract and that app that I created. And let's do that real quick just to see that. And again, it's not just an attester app. An attester app with a price curve that we built. We added the price curve in about 15 seconds, right? It was just that extra little bit that we added right here that gave us that price curve. And it was sort of like a last minute, let's put a price curve on it. Woo, okay, let's do it. And so there's a lot of just playing around, prototyping, trying things. I'm seeing if anybody has written anything dirty yet. They haven't. Great. Okay. Awesome. Hearts. Send. There we go. We're all using a decentralized app that I built in like 2 minutes, even with a bunch of things breaking, right? This is what Scaffold ETH is all about. So Google Scaffold ETH, you should be able to find the repo pretty easy. Get into this routine where you change a few things in Solidity. You go to Solidity by example, and you look at some of these topics. You paste them into your contract. You tinker with that front end here, and you kind of poke at your contract and make sure, wait, did this work? I think we're still waiting for that to go through. Might be trouble with the RPC too. Rapid prototype your app. First, get Scaffold ETH down, learn Solidity, but then once you have that and you're able to quickly iterate on things, then it's like, the world is open to you. Now, this is just the starting point. Now that you've got the starting point, Scaffold ETH is also not just a starter kit for learning, but a starter kit for building apps. And it's very, very forkable. And anything you build with it then becomes very, very forkable also, right? So all these people know exactly where your contract is, and they know where your code is. They know where that home.jsx is, right? So then what we've done with this nice little, this is sort of like a dApp starter kit. We've used that to create a whole bunch of other starter kits, Optimism starter kit, or Proxy Factory, simple streaming, oracles, NFTs, sign in with Ethereum. There's so many different example branches. Seriously, if you go, let's go to the Scaffold ETH org. So that's just github.com/Scaffold ETH, right? Scaffold-ETH. And I'm going to Scaffold ETH examples. I'm going to paste these into the chat because I want people at home to go check this out. How many branches? 262 branches. Let's go look at the, how do I look at the active? Here we go. You're not gonna be able to see it, but ooh, what do we got right here? Etherscan starter kit, a token multi-drop, a multi-sig, a ZK Circon starter kit, a ZK game example, a Uniforker. I don't even know what that is. Retro PGF funding with Optimism, some Matic starter kit, some ABI thing. Don't know what it is. There's tons and tons and tons of examples here where you can search for the thing you're looking. What if you're looking to learn commit reveal? Let's just say, what the heck is commit reveal? We want to learn it. I'm gonna go to Scaffold ETH examples. I'm gonna go right here and I'm gonna type in commit. Look at that. There's 3 different commit reveal tutorials that you can get in here and follow. All of these have these nice readmes that are focused on helping you get up to speed and figure things out. Look at all of this great information. All right. So lastly, as you're building cool things, there's even incentivization mechanisms. I'm streaming to builders that are building prototypes and products and tutorials and templates for other builders. So if you happen to get, that Circom starter kit we saw over there, definitely YOLOing ETH to whoever built that, right? I want more and more and more of these composable generic components that we can grab off the shelf and make some kind of product or prototype out of. And this is the way to do it. This is the way to do it. Get scaffold ETH, tinker with Solidity, then grab some branch that gets you dangerously close to the product you want to build. Tinker with it, 3 or 4 examples of it, throw it at the wall, see how people use it, and iterate on that. Post that repo back. I'll YOLO some ETH to you, and we can create this kind of like nice cycle of development. And then kind of stepping up from that as a Moonshot Collective beyond Build Guild, we have the Moonshot, which is focused on DAO tooling and prototyping. So as builders kind of look at these things, they get scooped up into Moonshot or other orgs in the space that are looking to build these things. But really, I'm talking to you, builder. I want you to build your own thing. I want you to take scaffold ETH off the shelf. I don't want you to go work for sushi. I want you to build the next sushi, and I want you to do it by just grabbing scaffold ETH, tinkering with things, and learning as you go, and then finding some of these projects and prototypes that you can fork, like the Punk wallet. That wallet that I was using there. How do we get the Punk wallet? Well, I'm guessing we're going to go to scaffold ETH and we're going to type in Punk. There it is. There's the Punk wallet. This super forkable web wallet with Wallet Connect first is right here. You can fork it, and in 10 minutes you could make radwallet.io, which is a Punk wallet that uses the RAD token, right? So much.
I wish you had more videos about the Ethereum speedrun and talking about low level stuff with this tool here that he created. I forgot where I found those series of articles. Maybe I saved them here. I'm pretty sure it was from him, but I forgot where I saw it. Maybe I can go back on my own video and see if I can find the link. Hosting. Let's go find it. I'm pretty sure it was from this guy though that I got the articles that time.
We're back. Awesome. I can't do it as cool as you, Austin. I'm sorry. I don't have a bow tie. So
to throw props to Alex right away, like a lot of times when I take my smart contracts to someone smarter than me and say, what am I missing? A lot of times it's like, why are you still reading that? You're doing that read every time when that can be a local variable. You're reading from storage every time. Quit doing that, knucklehead. This should be immutable. This should be constant. Like you got to get those things going. And it's something that I always forget. There was a good talk.
Same here. That's happened to me so many times. It's worth calling out for sure.
Awesome. So I'm going to start off with some silly questions first, if that's okay. So first question for Alex Rowan. What would smart contract Vogon poetry look like?
Horrific. Unbearable. unreadable, unbearable, and it would sound crap.
And it would probably use a lot of storage, I would imagine.
Oh, all the storage. Yeah. We'd max out all the gas for every block. Yeah.
Awesome. And then a question for you, Austin. Where do we get a bow tie like that?
This, I think my sister-in-law got this for me. So this is like a fancier one where it's like straight across. Like I feel like it just has a little bit more style. Most bow ties are kind of clowny and kind of poofed out, but definitely the key to buying a bow tie is buy one that's the actual stuff that you have to tie. Don't buy one of those like pre-tied ones that you like clip on. You look like
I want to brush my teeth for Breva.
you look like a turkey.
Awesome. Thank you for indulging a couple fun questions. Let's dive into some real questions. And so I want to start with you, Alex Behrens. OpenZeppelin has one of the best libraries for contracts across the whole ecosystem. How are you preparing for Solidity version 09?
I can't quite say too much, but we will be unveiling a bunch of different solutions in the next couple of months. And right now we're really focused on governance, but 0.9 is certainly in our pipeline, and we will most definitely be sharing that. We have more to share there.
Awesome. So we've got a whole class of questions about the level of skill and knowledge from all of our speakers. And so maybe I want to ask everyone, how did you get to your current level of skill and knowledge and amazingness? So Austin, why don't we start with you on that? Like if someone wanted to follow in your footsteps, what should they do?
Well, like, first of all, I'm still not a very good smart contract developer, right? Like the level of intricate detail it takes to create a good smart contract platform is way beyond me. It's like super heady, and we need more folks like that in the space. Like audits are like particularly hard and complicated, and not enough people know how to audit. So I'm not a genius, but to get in, it was just a lot of tinkering. It was a lot of trying. It was a lot of trying to find like product market fit. Like I made a few games at first and it didn't stick. But then I started building tools and I started writing about those tools, and the ecosystem liked that. And that kind of helped me get into the space and contribute. I would say just for someone to follow in my path is just keep building cool things and keep tweeting about them and writing about them and try to help other people to get started. But it's just getting, like Patrick said, and I reiterated, like it's getting your hands dirty and it's playing around with it.
Awesome. And I'll turn it to you, Alex Behrens.
I had kind of a fun introduction. So I worked at Hitter Hashgraph back in, 2017, 2018, and then I kind of moved away from the space for a little bit. And then summer 2020, I started using a number of DeFi applications, got really into it, just got excited by the whole ecosystem. And I just randomly happened to be the 10,000th person to start the OpenZeppelin contracts library. I was just tinkering around. And then the guy who had my previous role reached out. He said I was going to send you some socks and some other stuff. And then our head developer was like, "We're hiring." check that out. And then I started I think it was a 4-month interview process with them, and clearly worked out.
It sounds like you got tricked by like a banner ad. You went to 10,000 person star repo. Click here for a job.
When I checked that Twitter notification, I saw that, and I did think that it was some scammy thing. But then it was Andrew Kothrop, who now heads up, I think it's called This Week in ETH, which is a pretty popular newsletter. So shout out to him. He's fantastic.
Awesome. And we'll get to you, Rowan, in a second, but I just want to continue on this topic a little bit because Austin mentioned that we need more auditors. And I know that Open Zeppelin is like, you have a backlog a mile long of audits. Like you're not actually looking for new audit customers right now. You've got so many. How does someone get into auditing or become an auditor?
So there's actually a number of paths that our auditors take. Like some are just straight up hackers who try to find every vulnerability in the system, and we're kind of maybe on the wrong side of the tracks at one point. But we also have math PhDs, people who work in physics. It's really just about people who are trying to find innovative ways to break a program and create an exploit so that the bad guys don't do it first. And there's, I think, far more smart people in the space who want to prevent this type of thing than cause it. So that's really encouraging. And I think our team is a great example of that because all of them are absolute like mad geniuses, and they all have these fantastic math backgrounds and hacker backgrounds. And working with all of them, just speaking with them on a daily basis is really, really humbling. So you can come from any walk of life, but you need to be an excellent problem solver to be an auditor. That said, if you think you have the chops, feel free to reach out to us.
Awesome. And then back to you, Alex Rowan. How did you get where you are? Because I feel like a lot of people underestimate how both easy it is to become an expert, and then also how rare and powerful and important that knowledge is. Like Alex Rowan, I would call you probably, I don't know, top 5 smart contract optimization experts in the world.
That's a stretch, but
Yeah, so I understand this kind of stuff here in MathStar. I think I already understand this a little bit, but not really well. And this assembly as well. This kind of stuff. This is the project from OpenSea, I think. It's all their contracts. It's called C Apart. And it's obviously a lot more advanced than the stuff that I have there with my 2 contracts. And they, from what I've heard, I think Austin talks about this, that they use the assembly or something close to assembly to create this library here. And that's the kind of stuff I want to understand more, I think. Maybe I can check to see if there is someone that made a video explaining the yellow paper, instead of just reading the... Because I remember I opened sometimes and it's a lot, it's very big. Not very big, but I think it's gonna be tedious to read. It's probably very difficult as well to understand what's going on there. Yeah, there's some math. Oh, I remember I seen this one before. Maybe I'll watch it again. And this one. But I think the thing is, this is gonna be essential to understand for the stuff that I wanna do. Because first I need to understand what kind of information I can have access to. Because I have these ideas in my mind, but it might not be possible based on the amount of stuff that I can get from the contracts, the transactions. I remember when the first time that I was trying to get information for the other project, that the roadblock that I got into was that it was difficult to get some functions. I remember there was something like that in order to get some information about some functions or different contracts, should be able to differentiate a personal wallet from a smart contract, and to be able to get information about some certain functions inside of the smart contracts, you had to run your own node. Otherwise, it wasn't possible through these APIs. And there was some stuff about that. And I think it's also related to the other project that I was doing before I got into blockchain and this kind of stuff, which is to be able to visualize the script execution in Python. I think it's very similar things where I have to understand the OP codes better and the function scope and the operational system as well, to be able to understand what kind of information I can stack trace, if that makes sense. Because in the same way, the other project, the thing that I was trying to do was to keep track of the things that I couldn't see just by looking at the source code. And that's why I wanted to do that script visualization stuff. So I'm able to capture the information that is being transferred from one function to the next and from one file to the next, and that I can't visually see just by looking at the source code. And I think it's very similar here, where I'm gonna be trying to visualize the stuff that is happening on the blockchain. In order to be able to do that, I need to understand the operational system, the difference in the protocols, and how the OP codes work and the structure of the thing. And it's not really clear in my mind, so I think I won't be able to avoid reading this. Or my only concern is how much time for each thing. That's always a question, because there's so much information and so much stuff to learn. I think I found this information for this one. Yeah, this article here. And I really like the Ethereum page as well. I think they have a lot of articles and good stuff in the Ethereum org. So far from what I read is really good. And unfortunately, I don't have the money to buy the hardware that is necessary to run a full node. And it also takes a long time to get all the blocks. Probably 1 or 2 months running straight without disconnecting, in order to fully update the blockchain, and probably 2 terabytes or more, something like that. It obviously increases every year, and the more people that make transactions, it just increases more and more. Which is another thing that I'm not sure if they took into account when they probably did, but I'm interested to see if there are any calculations on that, on how much hardware and how much of this stuff is going to be needed in the future. Because if it's 1 terabyte now, then obviously 10 years from now, or the more people that use it, it's going to be insanely difficult to run a full node. So I think the tendency is to become more and more centralized, and especially with collusion, because that's probably the reason why I think that blockchains are not decentralized. It's just changing the power from the governments to people that have money, because it's pretty much the same thing. You're not escaping from the market economy, from the way that market economy works, which is the natural equilibrium of the arms race. And eventually everything converges to operator distribution, because the regulation forces don't have enough force to counterbalance the expansion. So the mass becomes a vicious cycle, and then eventually everything goes into an exponential distribution. And the more power you have, the faster is the conversion, because it's a self-fulfilling prophecy, let's say. So that's the problem with the blockchains, is that it is more decentralized, I think, than the normal way, but it doesn't change anything, because it doesn't change the principles of the market economy. You're still relying on supply and demand. So I guess that's one of the things that I want to do, and that's why I'm excited about trying to get the information, because maybe if we are able to get data from the blockchain and understand how markets evolve over time with this data, and train machine learning algorithms in order to find some kind of fractal pattern that's capable of regulating this tendency of things becoming exponential distributions, and the system becoming not corrupt, but falling out of equilibrium. I think that's probably a good thing. And it might give me an insight on maybe how to create something that's capable of replacing market economy. But obviously that's extremely hard, and there's probably a lot of stuff that I'm not thinking about the details of everything and all the variables and all the complexity that goes into that. And probably doesn't even matter anyway, because artificial intelligence is already extremely powerful and unstoppable, probably. But there's nothing I can do in relationship to the singularity, so, or the tendency towards the singularity. And because it's unpredictable when it's gonna happen, it may take a bunch of time or it may happen really fast. There's nothing to do about that. So I think the best course of action is just to think about ways to maximize the probability that we won't destroy ourselves with technology. And I'm not really sure if the yellow paper talks about everything that I want to know, actually. But I think I'm gonna have to read this as well. It takes time as well to understand, because the brain forgets the information. Oh, also the proof of stake stuff. I remember reading a bunch of things about it, but I kind of forgot a lot of it. To see what's gonna be the difference between proof of work and proof of stake. I know what proof of work and proof of stake is, but to understand the validation and the nodes, how it happens on the code. Like the algorithms and the hash functions, stuff like that.
I'm going to name drop Austin here and some of the videos that he makes, genuinely. And people like him, like Patrick, who make awesome intro videos into smart contracts. That's definitely how I started. Learned loads from there, and then even I remember kind of graduating from the videos and tutorials to kind of digging through the Open Zeppelin contracts. I know that's just a bit of a coincidence that we have the two guys right here, but that's true. And then joining Chainlink, just finding someone who's better than you and hounding them for questions. That's always the best way to go.
I'm gonna watch this video more and maybe this one, and maybe this one, and then I'm gonna read these articles again until I get tired. Probably the 3 first ones I'm gonna be able to do it. Then after that I'm gonna start this one, I think, or maybe glance over. I remember now that I was doing this one, but I stopped the beginning, and you pretty much have to write the functions here that I think I already did for this staker. Yeah, you need to create something to allow people to stake money, and then you need to find a way to put a deadline. Remember I did it like this, but I wasn't sure if it's correct or not. And the problem I found is I understand why he does this way, because it forces you to go after the information. But the issue I found is that I'm not sure if the things that I did here are correct or not, and there is no explanation on the Ethereum speedrun about the correct way to do it or the best way that people found. So that's the only downside of the way that he did it. But I understand why he does it this way. Otherwise, if you just give the information, people don't learn things. I think I'll close. Maybe at some point I should study this as well, but this is a lot of code. This is difficult to see where to start here. Hey, Percy. Percy CF. What's up, man? But I think I'm gonna close this one for now.
Speedrun Ethereum. Check out ETH hooks. Check out Build Guild. Check out Moonshot. Whoop whoop. Happy Bowtie Friday. Hearts, 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 hearts. What's up, Luke? How you doing, man? Are we good?
Oh my god, I don't even know how to follow that up. That is the best. This is the best Bowtie Friday that I've seen. I need to get a bow tie, and I need to be there for the next one. Thank you so much to everybody for joining us today. Thank you, as always, to Austin. It's been an incredible presentation as usual. I'm going to post some of the links you shared in the Discord in case anyone needs to see them again. As a reminder, the Zoom chat's going to be closed after this, so I highly recommend connecting in Discord, continuing this conversation, keeping that energy up, and
keep building. Go build something awesome. Sunday's gonna be insane, right? What, Sunday at 6 p.m. or something like that? Sunday evening.
Oh yeah,
we're gonna see some scaffold builds.
I'm sure you will. I'm sure you will. Thank you.
So what's the best way to hound you for questions?
Tweet me.
Awesome. I want to go back to Austin for a second. You showed off these amazing branches, like all the different branches of Scaffold that are showing off 1,000 different things, the way you're incentivizing more people to create these. Are there any particular branches you'd like to give a shout out to that you think would be a great place to start as being like really good or really helpful?
They're even linked. And if you Google like ETH speedrun or speedrun ETH, just Google that, and the top thing is going to be an Ethereum speedrun, and it's going to take you through all the branches. It starts with, hey, grab Solidity, tinker with Solidity, or grab Scaffold ETH, tinker with Solidity. But the top branches that you're going to want to hit right away. I used to have people start at challenge 1, where you're building a decentralized staking app. You learn payable functions. You learn how to send ETH and lock it up. You learn the timing. But I think the simple NFT branch is the best place to start, because you kind of like get an NFT contract. You're able to mint an NFT. You're able to send it around. So my shout out branches are simple NFT example, then challenge 1, the decentralized staking, and then challenge 2, which is the token vendor. It teaches you contract to contract interaction and kind of gets you leveled up. Even like the approved UX pattern of ERC20, that's kind of tricky. So those are my starting points. But commit reveal is important. Sign messages are important. Uniswap, like build your own little price function and build your own little simple DEX, like a Uniswap V1. Like implement that yourself in Solidity. It's only a few lines of code and it's mind blowing. And then let's see. Randomness is really hard on chain. Figure out how to learn how randomness works. Like figure out how commit reveals, chain link VRF. There's a lot of tricks there. You can get into oracles a little bit. So that's probably more branches than you wanted. But that's my whole speed run.
Awesome. And let me ask a crazy question. Do you think there could be a collaboration between Scaffold ETH and the Smart Contract Wizard? Like that feels like maybe a natural pairing.
I'm down. Sure. I'm always on the hunt for a good collab.
Let's do it.
Awesome. One time we did like a mentorship session where some Open Zeppelin dudes got on, and I kind of like did a live coding of, I think it was challenge 2 with the token vendor, and they dunked on me like 5 times for sure. Like having an expert there on Solidity, like as we're working through the Solidity, like I did a dot transfer. And it's like, oh, actually don't do dot transfer. If you transfer to a smart contract, the gas is gonna be limited, it's gonna fall apart. What you want to do is dot call with the value in there, and then you put the parentheses, but you got to do some quotes in there too. Like why is this so complicated? But I needed the Open Zeppelin guys to be there to help with that. So I'll take a wizard on a collab anytime.
Fantastic. I'll ping for you.
Awesome. Next question is for Alexander Barons. You have a lot of public audits that are like really useful. How do folks figure out which audits they should be like taking a look at? Like what's worth their time both to learn and to get better at?
I think just filtering through whatever projects are most similar to what you're thinking of building would be the first step there. But I'd really encourage everyone to join our security development series, and I'll post that link in the chat here in a second. Because although our audits are, they're great case studies, this security development series is being hosted by one of our most seasoned auditors who's now transitioned full time into thinking about how we can better educate people in Solidity security. And these is going to be a 6-part series. We have recaps, and he's sharing a wealth of information here. So I think that's going to be even better than our audit reports, because those are just case studies, and this is how to prevent those case studies from happening in the first place.
That's awesome. Thank you. Back to Alex Rowan. There were a lot of questions in the chat about some of the basics around smart contract development. So maybe I'll kind of pose a few of these. So what is the EVM? What are opcodes, and who executes smart contracts? So those are kind of connected concepts.
Okay, what is the EVM? So the EVM is the machine that nodes run on the execution layer. So it's where smart contracts live, and it's what nodes execute when you interact with dApps. What's the EVM? What's the second one?
What are opcodes?
What are opcodes? Okay, opcodes are they're specific instructions that the machine level instructions that the EVM understands to do specific things. So if it's like we went through store and sload. They mean store this data at this specific storage slot. It tells the EVM to do that. There are opcodes for memory, so pushing things onto the stack, taking things off the stack, adding, subtracting bits. Every single operation that the machine can perform has its own opcode at the lowest level. What was the last one again?
Who runs smart contracts? I think there's some confusion around like who's a miner, what is a node, like those sorts of things.
So there's we use a phrase sometimes. Autonomous smart contracts. They're not really autonomous. It has to be poked. Someone has to poke it. And I think that's a distinction that we need to make. So smart contracts, if no one interacts with them, they just sit there and they do nothing. They can have the best logic, the most efficient way of interacting with storage. But you as an externally owned account, so me at my address from my MetaMask account, I can go call a function and that will kick things into gear. So there has to be an EOA, an externally owned account, to actually kick smart contracts off. And then they are run by, that transaction is run by the nodes when it's propagated across the network.
This is a really neat point though, because like from a developer standpoint, if you think of a cron job, you think of this thing that's going to execute regularly. But when you realize you can't run a cron job, what you have to do is actually thinking of a world of adversarial jerks. You have to incentivize someone to run that cron job for you. You have to build it into the contract for someone to walk up to that vending machine and poke it every once in a while and financially incentivize them, maybe financially, but incentivize them in some way to walk up and poke that button. And it changes your understanding of what Ethereum is. It's more like this like big vending machine like that anyone can access rather than a backend server that can run a cron job.
And the other option is Chainlink keepers. So if you do need a cron job, use a Chainlink keeper.
Or vendor, by the way.
Awesome. So next question I think anyone could take, but maybe I'll pass to Austin. Is it too late to learn Solidity as a beginner? I only have 3 years of JavaScript experience.
Oh man, no, that's plenty. you like if you can do a for loop in JavaScript, you're ready to start tinkering with Solidity. You're not going to be a Solidity expert. You're not going to like deploy a contract and have millions of dollars in it. And if you have that mentality, that's okay. But get started tinkering right away. Like that's the point. Is to Solidity is pretty simple, right? Going back to it's like you're coding a little embedded controller. Going back to the EVM. The EVM has to be a pretty simple thing so it can run on all these machines successfully. So the language is pretty simple. You're just setting some storage locations. You're updating stuff. You're writing small control loops. Like it's not super complicated to write. So I would say with just a little JavaScript experience, I would start there. Like I would go look at like famous universities have great web dev programs. There's a bunch of like Kickstarters to get your web dev going. Find some good web dev tutorials. Do that. Learn JavaScript a little bit, but jump right into Solidity once you've kind of got the flow and the handle for thing, knowing that like don't jump into Solidity and be like I'm gonna make $1 million next week by deploying something to mainnet. Jump in and tinker and play and learn.
Awesome. Question up next for Alex Barons. Defender has a lot of features. Where should I get started?
I think the best place to get started is probably by going to our YouTube page. We have a bunch of different use case demos for Defender up there, as well as just a general intro. You can also head over to our events page where we host a bi-monthly Defender demo with our head of product and sometimes our CTO. And we just walk through Defender. Of course, you can visit the docs and sign up at defender.openzeppelin.com. But I highly recommend that you check out all our educational materials because they're very, very thorough. I think you'll find.
I still don't understand really well when he talks about Ethereum is more like this vendor machine. I don't really understand what he means by that. The difference between the cron job stuff and the vendor machine. I guess I think I kind of understand where nothing activates the smart contracts by it can't activate by itself, so people need to be incentivized to interact with it. Otherwise, it doesn't work. But in my mind, it's the same way with the cron thing, where someone needs to run a script or yeah. But I guess that's the problem. I don't really understand really well the cron job stuff because I never used it or tried to implement it. Yeah, but I'm not sure. Because in my mind, it would be possible to create scripts that combine, let's say, for example, we have a cron job and the cron job activates functions on a smart contract. So it's kind of the same thing. You don't need someone, you can just program, but obviously it's not going to be fully decentralized because then you're going to have decentralization, but full decentralization doesn't exist because decentralization only exists in relationship to decentralization. It's just a matter of the distribution.
Awesome. And maybe one more question for you, Alex Barons. What's OpenZeppelin's stance on potential future threats like quantum algorithms? Are there any initiatives in place to combat them?
I think that we have a number of initiatives that are going to be announced, I believe, in October that might answer some of those questions, but I can't say anything on that right now.
Where should people go to stay in the know?
You can head over to our blog as well as our Twitter. We're going to be posting everything on there. So I think we should have big update in the middle of this month as well as the middle of next month, and then also in October. So you're asking.
Awesome. And then the last couple questions here, I'm going to go to Alex Rowan because they're connected. So where can we learn more about gas writing efficient smart contracts?
So that was one of the reasons I did the talk on that, because the detail that I went into, it's like Austin said, it's feedback we get from auditors a lot of the time. I believe there is resources on the Ethereum Foundation website. I know that's been beefed out quite a bit recently. And there's always the white paper, the original white paper, it could be in the yellow paper, the each opcode's associated gas costs. And these change over time, so watch out for EIPs like 2929 that changed how the gas costs of storage are applied.
Awesome. And then are there any final question? Are there any good profilers to help see execution costs of individual statements or blocks?
Yeah, so we use Hardhat for our testing suite in Chainlink, and there's a plugin you can get with Hardhat called I think it's just Hardhat gas costs or something like that, and it will print out once your tests are finished. It will have recorded every transaction that your tests performed on the functions of your contracts, and it'll print a table for you that gives you the least amount of gas used for that function, the most amount of gas it used, and the average. So it might change depending on the path through the function, so with conditional statements and whatnot. So that is a pretty good profiler. Highly recommend anyone using Hardhat to include that in their test suite.
Awesome. Well, we're out of time. There's lots of great questions.
Julian, and in this video I'm going to talk about whether or not it is useful to study the yellow paper of Ethereum when you want to learn Ethereum programming. So there are two important documents that describe how Ethereum works in general. The first one is the white paper of Vitalik Buterin, the creator of Ethereum, and the second one is the yellow paper that was authored by Gavin Wood, if I'm not mistaken, which is the co-creator of Ethereum. So there is a lot of misunderstanding about these two documents. So the first one, the white paper of Vitalik, so it's actually just a high-level description of how Ethereum is going to work. This was written at the very beginning of Ethereum. I think it was written in 2014. So in the meantime, a lot of things have changed. So if you read it, you'll find that some of the description are already outdated. But what I like about it is it's quite high level. It's not too long. It's easy to understand. So it's like maybe 5 or 6 pages. So it's quite easy to read it and to understand it as when you have your first glance at Ethereum. This is quite different from other white paper like the Bitcoin white paper. The Bitcoin white paper is very technical with a lot of scary mathematical notation. The white paper of Ethereum is not like this. It's very easy to understand. So it's really good to really get started. And the other one, the yellow paper, that one is actually very technical. It's a long document. It's like maybe 60 pages, and it's full of a very scary math notation. And so it really describes how Ethereum works in detail. So it really talks about the implementation. But what I really don't like about it is that it uses this mathematical language to do all this description. And to me, it really adds an unnecessary complexity. So if you're just getting into Ethereum, I don't think it's a really good idea to spend too much time on the yellow paper. Where the yellow paper might be interesting is if you have a very specific question, for example, about opcodes, so the elementary operation that run inside the Ethereum virtual machine. So you have some appendix that describe all the opcode and the gas cost, for example. So it can be useful for things like this. But otherwise, unless you're a researcher, I would not recommend to check out to spend too much time on the yellow paper. Just read the white paper and Google all the stuff about Ethereum, and it's going to be better than the yellow paper. So that's it for this comparison between white paper.
Yeah, so it looks like I'm probably gonna have to read it. I don't like as well when these papers, and I understand why they do it, but I don't like that they have heavy mathematical notation. It would be good if they put the description of each symbol somewhere, because a lot of the symbols I don't know what they are or I forgot about it. And it's not like the math is really hard, it's just that if you don't understand what each symbol means, then it becomes impossible to, or not impossible, but it takes a lot more time to understand what's going on. It's like on the Uniswap papers I read some time ago, that the math is not that hard, but if you don't understand the symbols they are using, then it becomes really hard to understand what's going on.
Hello, everyone. Welcome to the third day of the conference, Deep Dive into Ethereum Protocols. So we started off with a wonderful presentation from Alex on the protocol on top of which the other Ethereum protocols run. So I figured it makes sense to follow that up with a presentation on the Ethereum protocol. So, the idea behind the Ethereum blockchain first came around back at the end of 2013 when people were getting really excited about Bitcoin. People were starting to get excited about blockchain technology and applications beyond currency. And there's a public consensus that blockchains are useful for stuff and not just money. So, blockchains could be used for asset issuance, crowdfunding, domain registration, title registration, gambling, prediction markets, IoT. People are coming up with some new category of applications every week. And so, the problem at the time is that most existing blockchain protocols were designed like this. Single-purpose tools that are specifically designed around one particular application. So in Bitcoin's case, currency. In Namecoin's case, domain registration. In Primecoin's case, trying to do scientific computing, and in my opinion, not doing a very good job of it. So then we had second-generation protocols that looked like this. So we had protocols that had somewhere around 55 different transaction types, where one transaction type is something like, create a binary option, another one is join a binary option, then one for settling a binary option, one for making a bet, one for settling a bet, one for doing some kind of two-party dice game. And every time someone came up with a new kind of application that was deemed important enough to be worth including, the people who were creating these protocols would just add yet another transaction type. So at the time, we had protocols that had 55 transaction types. I even worked for one of them for a few weeks. After I worked for one of them for a few weeks, another 2 transaction types got added. Good old contract for difference. So even still, it's pretty obvious, I think, especially from the standpoint of our current generation, that this particular way of doing things is just fundamentally limited. So what's the solution? Basically something like a smartphone. So, the idea is that instead of So instead of having a protocol that's designed around one very small set of use cases, you just create a general purpose operating system and you let people build whatever they want as applications on top of it. So if you do that, then things suddenly become better. People maybe when you're inventing the protocol, you might be thinking that okay, people are going to use this for binary options, contract for difference, making two-party bets, doing domain registrations, and whatever other 50 applications you were aware of at the time. Then release the white paper, and 6 weeks later you realize that people are inventing applications in a completely different direction. And guess what? Your protocol does not even have to change one single bit in order to handle them. So that's the power of generality. So what is the concept behind Ethereum? Well, it's a blockchain. Seen it for 6 years, pretty boring. There's a few tiny additions. So the first important one is this concept of a built-in programming language. So in Ethereum, there is a kind of a built-in Turing complete scripting language. It's essentially a hybrid between kind of standard virtual machine architectures, Bitcoin script, and a few other things. And the point is that people can write programs in this script, or more realistically, in high-level languages that compile down to the script. Then people take their compiled scripts, put them into transactions, and send the transactions off to the blockchain. Transaction gets confirmed, an address gets generated, and you now have a special kind of account at that address called contract. So two types of accounts. User accounts controlled by private keys. We all the same old elliptic curve digital signature algorithm we all know and love. Second kind of account, contracts controlled by code. So these two types of accounts in Ethereum essentially have completely equal privileges. Anything that humans have the right to do, bots have the right to do. So anyone can create an application with any rules by defining it as a contract. So this is essentially the basic principle. So, the whole world of Ethereum, like creating a decentralized DNS system. So basically, the idea here is you want to create a system where people can register addresses, and if they, addresses could be, something.eth, and if they own an address, they should be able to set the IP address associated with that domain address. So the way the system works is fairly simple. So you see a sort of declaration at the top, data domains, with an owner, basically a mapping between a domain name and a tuple containing an owner and an IP address. And you have two functions. One of them for registering a domain, which basically says if this domain doesn't have an owner yet, then sends the owner to, or set the owner to whoever sends that particular transaction. And you have another function, set IP address, which basically means if you own a domain, then you set the IP address to whatever you want to set it to. So very simple rule set. This is, and of course, real life DNS systems have substantially more features to them, but sort of the fundamental core basically stays the same. And you could probably build a more complex DNS system on top of this just by turning the IP address into a hash and throwing everything else on IPFS if you really want to. But point is, very simple logic. You can write it in 10 lines of serpent code and publish it to the Ethereum blockchain, and there you have a system that's basically like Namecoin. So this is basically the meaning of anyone can create an application with any rules. Once this application gets created, then anyone can interact with the application by sending transactions that specify the contract's address as their destination address. So you send a transaction to a contract, and that's how you talk to the application. That's how you call functions. That's how you do whatever it is that you want to do. So in Bitcoin, the state is very simple. It's basically just a mapping of technically speaking, the sort of list of unspent transaction outputs. But what it basically means in practice is just the list of balances, the list of sort of the amount of Bitcoins that every particular person has. And if you want to do a currency system, that's basically all you need. In Ethereum, the state is kind of more complex. It's a sort of key value mapping going from addresses to account objects. And there's two types of account objects. One of them is a sort of simple accounts controlled by private key. In that case, all you have is a non-set of balance. The second kind is accounts that are controlled by code. And in that case, you have these extra two fields that get filled up. One of them is the code hash, so the hash of the code of that particular account. And the second is the storage tree root, which in a sort of fairly intricate way that I'll describe later basically represents the entire sort of storage of that particular account. So for example, if I create a contract with this code and register a domain, then the fact that one particular domain got registered and it got registered with me being the owner, and then they set the IP address to some particular value, that information all goes into the sort of persistent storage of this particular account. So basically, mapping from addresses to blocks of this is the entire state of the Ethereum system at any particular time. So code execution. Every transaction specifies a to address that it's sending to. So this is fairly simple. It's the kind of logic that we all understand. If you send the message, then you generally specify who you're sending it to, and you want to specify the contents. So what happens if you send a transaction to the to address? Well, two options. One of them is that the destination address is just a private key control account. In that case, all you're doing is moving ether around. So if you do that, then it's basically just being a cryptocurrency. What if you're sending to an account that has code? Then what that's doing is it's basically activating the code, and it's actually letting the code run for some number of steps. So code in Ethereum can do three things. Number one, you can just send ether to other contracts. Number two, you can read and write from the contract's own storage. So for example, if you're going here, then the way that I would call the register function is by sending a transaction with data formatted in a particular way. And what that function is going to do is, or rather, what that transaction is going to do is it's going to start running the code that actually represents the register method. And where it specifies self.domains address.owner equals msg.sender, that's setting a variable. What that actually gets compiled to is setting a particular key in the contract's own storage. So then the third thing code can do is you can call or basically sort of create these sort of virtual transactions that go to other contracts. So theoretically, I could create another contract that has some different set of rules, and that contract itself can actually interact with this contract. And that contract itself can register domains, it can set an IP address of domains, it could theoretically do just about anything that an account controlled by an address can do. So every full node on the blockchain processes every transaction and stores the entire state just like Bitcoin. It's bold because it's important. So this is sort of one of those points that's important to make because people often ask, well, if I publish transactions to Ethereum, who's actually who's actually going to be enforcing the contracts and how many nodes are running them and so forth. For Ethereum 1.0, the answer is very simple. Every node in the network runs every transaction, and the process of running a transaction, if that transaction goes to a particular contract, it actually involves executing contract code and setting and sort of changing the state to whatever the state is after the contract gets executed. So from that standpoint, you can actually think of it as being a rather fairly simple system. You can think of the state as being a database, and you can think of each of these contracts as being programs that are sitting on one computer, except the computer is massively globally distributed. It's actually a highly secure network backed by tens of thousands of computers around the world. So it's bold because it's important. So yes, this is one of those sort of key mechanisms underlying the security of Ethereum. So when you tell people that you have a Turing complete programming language and that you let untrusted parties send code that's executed in a Turing complete programming language by every single computer in an entire network, the first thing that they're going to ask is, well, what about the halting problem? So there's this very widely known result in computer science, which basically says that it is mathematically impossible to create an algorithm which can tell whether or not any given program is just going to keep on running forever. So how does Ethereum prevent attackers from creating programs that just keep on running on everyone's computers forever? And the answer is this concept of gas. So what this basically means is that the Ethereum network charges a fee for every computational step that a contract execution takes. So the specific way that that's implemented is that every block in the Ethereum blockchain has a gas limit, so basically a limit on computational steps. Right now the gas limit is set to 3141592, which is a nice number that we picked because we're totally not math geeks. And so then if you are a miner and you're creating a block, then chances are you're going to want to fill it with the transactions that give you the most profit. So every transaction specifies a gas price, basically an amount of ether that it's willing to pay per unit of gas, and it specifies a maximum amount of gas that it's willing to take. So a transaction might specify, I am paying 50 Shannon, which is basically 50 billion from an ether, per unit gas, and I'm going to consume up to 500,000 gas. Miners see all these transactions coming in, they select the ones that have the highest gas price, and they include them in their block. So when a transaction specifies that it's willing to spend up to 200,000 gas, then there's two things that could happen. One of them is that execution takes up less than 200,000 gas, in which case everything happens normally, it's okay, the transaction pays only for the computational steps that it uses.
I think it's a good idea to stop here and then read the article and then go back. Because I'm gonna get tired from reading, and then I can go back to the video, watch the video a little bit more, and then read the contract again. Go back and forth until I finish. I didn't read this one last time. I started from the second one. You're on the road driving fast in your rare, fully restored 69 Mustang. Installation, blah blah blah. Okay, could perhaps it sounds familiar, don't worry. The purpose of this series of articles is to deconstruct a simple Solidity contract. Look at its bytecode and break it apart into identifiable structures down to the lowest level. You'll pop the hood on Solidity. By the end of the series, you should feel comfortable when looking at or debugging EVM bytecode. The whole point of the series is to demystify the EVM bytecode produced by the Solidity compiler, and it's really much simpler than it seems. Note, this series is aimed at developers who already feel comfortable with and have experience in developing Solidity contracts, but want to understand how things work at a slightly deeper, lower level. That is how Solidity is translated into EVM bytecode by the Solidity compiler, and how the EVM executes such bytecode. If you aren't there just yet, I recommend reading the great introduction by this guy, A Gentle Introduction to Ethereum Programming. Here's the contract we'll deconstruct. So it has a total supply, mapping, true address, and a number called balances. Initializes the balances with message.sender, true equal initial supply, which is the total supply. Or is it? Total supply. Oh, it's passed in the construction. Total supply, transfer. I guess that's the function that I was trying to access. It's probably part of a function from one of the standard libraries from OpenAPI that NFTs contracts have. So it requires two different address 0. Value lower than the balances messenger. Okay. This contract is susceptible to an overflow attack, but we're just keeping it simple here for the purpose at hand. Interesting. Oh. Doesn't have anything. Oh, this is interesting as well. Yeah, I'm definitely gonna look into this. The only ones I'm aware of here are front running and reentrancy. The other ones I haven't heard of. Compiling the contract. To compile the contract, we'll be using Remix. Go ahead and create a new contract by clicking on the plus button on the top left of our browser area. Set the file name to basic tokens. So now paste the above code into the editor section. The right hand section, go to the settings tab and make sure enable optimization is selected. Also verify that the selected version of the Solidity compiler is version 0.4. These two details are important, otherwise you'll be looking at slightly different bytecode from what will be discussed here. If you go to the Compile tab and click on the Details button, you should see a pop-up with all the stuff that the Solidity compiler generates, one of which is a JSON object named bytecode that has an object property. Which is the compiled code of the contract. It looks like this. That's completely unreadable, at least for a normal human being. Apply the contract. Next, go to the run section and remix. At the top, make sure you're using the JavaScript VM. This is basically an embedded JavaScript VM plus network. Ideal Ethereum playground. Make sure basic token is selected in the combo box. And enter the number 10,000 in the deploy input box. Next, click the deploy button. This should deploy an instance of our basic token contract. An initial supply of 10,000 tokens owned by the account currently selected at the top of the account combo box, which will hold the totality of our token supply. Lowering the run tab in the deployed contract section, you should see the deployed contract with fields to interact with its three functions: transfer, balance off, and total supply. Here we'll be able to interact with the instance of the contract we just deployed. But before that, let's take a look at exactly what deploying the contract means. At the bottom of the page in the console area, you should see the log creation of basic token pending, followed by a transaction entry with various fields: from to, value, data, logs, and hash. Click on this entry to expand the transaction info. Even though abbreviated, you should see that the data input of the transaction is the same bytecode represented above. This transaction is sent to the 0x0 address. And as a result, a new contract instance is created with its own address and code. We will examine this process in detail in the next article. Why do I see disassembling here? I'm not sure. I didn't read this one before. Just starting from the second article. To the right of the transactions data, I want to make sure I go slow though on these ones, so I fully understand what's about. But I'm probably, the thing is that it doesn't matter because you have to see a bunch of times to remember because the brain forgets. So. But I want to make sure that I understand everything that is going on. Especially these instructions here. I don't think I'm gonna do the remix thing though. Of compiling the contract. Maybe I should. Yeah, but yeah. Disassembling the bytecode. To the right of the transactions data is still in the console, click on the debug button. This will activate the debugger tab in Remix's right-hand area. Let's take a look at the instructions section. If you scroll down, you should see the following. So this, I think, is assembly or something close to assembly code. And is the version that Solidity compiles to. Maybe in order to understand this better, I'll probably read the yellow paper as well. I think I'll go back and forth with this and the yellow paper probably, because it's gonna help me understand. But it's gonna take me time, obviously. And maybe read this text as well. I think I'll close this one. Yeah, the only thing, I have to finish the other stuff as well, the NFT market. I think after I finish everything and I at least have the market fully working, all the functions, the pages, and all this stuff, then I can focus on this a lot more. Because what I really want to do is focus on the data analysis from the blockchain. That's what really excites me. But I think it's good to start reading this stuff now so that I go back to it, and then that way I have space for repetition. Because I'm just gonna become better and better at understanding this stuff every time I come back to it. To make sure that you're following the same set of OP codes described in the series, please compare what you see in Remix with the bytecode in this gist. Oh, the other thing I saw in a profile from one of the founders of Buildspace that he did a site that has the OP codes. I might search for that later as well. I thought it was really interesting. It's like a web page that has the explanation of all the OP codes of Solidity. So I think that's gonna be helpful as well. Yeah, I'm not gonna do the remix stuff. I'm just gonna use this one. This is the disassembled bytecode of the contract. This assembly sounds rather intimidating, but it's quite simple, really. If you scan the raw bytecode by bytes, 2 characters at a time, the EVM identifies specific opcodes that it associates to particular actions. For example, 060 push, add, move, stop. The disassembled code is still very low level and difficult to read, but as you see, we can start making sense out of it. But I don't see any of these addresses here. Oh, yeah. There are some numbers here, but it's mainly just the lines and the instructions. Okay. OP codes. Before we get started on our ambitious endeavor of completely deconstructing the bytecode, we're going to need a basic tool set for understanding individual OP codes such as push, add, swap, dump, etc. An opcode in the end can only push or consume items from the EVM's stack, memory, or storage belonging to the contract. That's it. To see all the available opcodes that the EVM can process, check out this handy gist from PyEthereum showing a list of opcodes. Interesting. I'm gonna save this for sure. Maybe I can fork this as well. It's just a good thing to have whenever I want to look at something. I'm not sure how useful it is though, because it doesn't have the explanation of what actually is. Just has the opcode and the hacks here. To understand what each one does and how it works, Solidity's assembly documentation is a great reference. Okay, that's really good as well. The language used for inline assembly in Solidity is called RAFU, and it is documented in its own section. This section will cover how the inline assembly code can interface with the surrounding Solidity code. Inline assembly is a way to access the Ethereum virtual machine at a low level. This bypasses several important safety features and checks of Solidity. You should only use it for tasks that need it, and only if you're confident with using it. An inline assembly block is marked by assembly. Oh, so that's the stuff that they were talking about. That's why I was seeing that on the Seaport project. So they do use assembly. Where the code inside the curly braces is called language. The inline assembly code access local Solidity variables as explained below. Different inline assembly blocks share no namespace. Not possible to call a U function or access a U variable defined in a different inline assembly block. The following example provides library code to access the code of another contract and load it into a bytes variable. This is possible with plain Solidity true by using address code. But the point here is that reusable assembly libraries can enhance the Solidity language without a compiler change. This stuff I also seen on Go. I think it comes from that, or Go has that as well, but I don't really remember the difference between this and the other operators. I just know that, I just remember that it's used, but I don't really remember really well what it does. Maybe I still have the course here. I downloaded a bunch of courses from ZTM when I did all of them, and I downloaded a bunch of them. I was gonna put them on the site, but then I didn't have time to do it, to finish. So I can visualize them, but and do them again. Yeah, I'm gonna do this TypeScript one for sure as well, because I've been seeing more TypeScript on a lot of different projects, and I think it's really important, and a lot of people use it. So I think I'm gonna slowly move on from JavaScript to TypeScript. It seems to be better in almost all cases, but I'm not really sure though. Where is the Go stuff? Oh, I don't think I downloaded the Go course. Probably because it's too much stuff to learn. But Rust I also want to do again, because I enjoyed the way that I think this was probably one of the best courses out of all of them, and I enjoyed at least from first impression, I really enjoyed the Rust language. But it might be too much to learn as well, so not sure, depending on how much time I have. Is short assignment a equal 1 var a int equals 1. Var a int equals 1 are same. Just read Microsoft Docs for TypeScript, that's enough. There are several short books on Go. My opinion enough as well. These are simple links except Rust. Yeah, I'm gonna have to do some project in TypeScript, because I already did the course, the full course, explaining everything. But you forget, right? It's not the same as doing the project or something like that. I feel like I only really truly learn once I try to implement this stuff. But at the same time, it's a question of time, how much time I have, because there's all this other different stuff to learn. So yeah, and I also heard that Rust is extremely difficult. It's easy. It's kind of easy to. There isn't anything that I saw that is that much difficult from other languages, but I can see that applying these things correctly is gonna be the difficult part, I think. And that's where it takes a long time for people to become good at it. But just the syntax is just very similar to the other languages. No, what's Tauri? But I'm not sure if I'm gonna spend time learning, because it's probably hard to become good at it. And like I said, there's so many things to learn. I think the main priority is learning Solidity really in depth, and the EVM and the blockchain in general, and then combining that with machine learning. So Python is gonna be. But I don't like that Python is low. But it seems to be the one that is the most used for machine learning stuff. But I think I'd rather learn C++ or apply C++, but because I like to understand how things actually work at the. Maybe studying compilers is gonna be good. I don't like having this simple stuff. Yeah. It is good, but it doesn't satisfy me, you know. I like to understand how things work better. And there's a lot of stuff that I use in Python that I try to look at the source code in C, and you can't find it because PyCharm doesn't show the source codes. So I think that's kind of stuff I still don't, which is the problem I have since the beginning, which is understanding how the language. I don't have a problem with using Python. I have a problem with not understanding how it's constructed, if that makes sense. So understanding the compilation process of one language to the other, that's the stuff that I have to spend more time learning, because I think it makes you better programmer overall. Tori, Rust Tori. That's probably this thing. Fast to read, what's more important, and write. Read by compiler, Go, you are trying to learn everything. Treat some errors as black boxes. Yeah. Unfortunately, that's what you have to do. But Python and Solidity are my main priorities, for sure. Then the rest is kind of like a... TypeScript is kind of... I think TypeScript I'm eventually going to learn by just studying all this Git, these repos and incorporating it slowly into my projects. And then watching the courses again, also. I don't really understand what this is. Be ready to waste years to learn all that. It is awesome for interfaces, obviously. My plan is to master Go. Yeah. Yeah, but I don't know. There isn't really an end goal, right? You always improve. So at least I plan to do this stuff for the rest of my life, probably. So eventually I'm gonna learn everything. Not everything, but I'm gonna learn all these languages. And the only problem is that you can't really focus on everything because there's always new stuff coming. So, but at least I'm gonna learn the fundamentals of everything, I think. And I think it's more important for me to understand the integration of everything, and then specializing only two or one thing. That's the plan, at least. Yeah, and what I'm focusing now with Python is the networking. That's also something that pisses me off that I don't know, which is understanding how the connections, the operational system creates the routing for stuff, and the parts and all of that stuff. I think that's very important to learn and to understand. For hacking as well, that's sounds really interesting. And for web scraping and for a bunch of different things. So it seems like it's something. And the thing is that all of these things are probably implemented in lower level languages as well, like C++ or C. So, maybe Rust as well. I think Rust is a systems language as well. Electron, but fast. Oh, that's desktop applications with JS. Got it. Yeah, it's gonna take me some time until I decide whether or not I'm gonna do something with Rust. But TypeScript, I feel like soon I probably I'm gonna watch the course again, do the course again, and then see if I can implement some of this stuff on my project, the NFT stuff. OP codes. Before we get started on our ambitious endeavors of completely deconstructing the bytecode, you're going to need a basic tool set for understanding individual codes. I think I read this already. Understand what each one does. Even though it's not one relationship with the raw opcodes is pretty close. It's actually an intermediate language between Solidity and EVM bytecode. Finally, if you can speak Scientician, there's always the Ethereum yellow paper to fall back on. There's no point in reading these resources from start to finish right now, just keep them around for reference. We'll be using them as we go along. Instructions. Each line in the disassembled code above is an instruction for the EVM to execute. Each instruction contains an OP code. For example, let's take one of those instructions 88, which pushes the number 4 to the stack. This particular disassembler interprets instructions as follows. So hex value for push, OP code, instruction number. Even though the disassembled code brings us one step closer to understanding what's going on, it's still quite intimidating. We're going to need strategy for deconstructing the whole thing, which has 596 instructions. The strategy. Problems that appear to be overwhelming at first usually succumb to the all-powerful, almighty divide and conquer strategy, and this problem is no exception to the rule. We will identify split points in the disassembled code and reduce it bit by bit, until we end up with small digestible chunks, which we'll walk through step by step in Remix's debugger. In the following diagram, we can see the first split we can make on the disassembled code, which we'll analyze completely in the next article. So creation, runtime. Yeah, remember it separates the functions, and then there's something when you create a contract that the construction is separated, and then there's a reference to each function on that thing. I don't remember really well though. You can find the end result of the entire documentation in the construction diagram. Don't worry if you don't understand the diagram at first, you're not supposed to. This series will go through it by step. Keep it around so you can keep track of the big picture as we go along. The series is divided into the following set of articles. Yeah, let's go to this one. So there's the creation and then the runtime. It's very big. It should, in theory, I think it should be possible to get all this information from all the contracts. Because everything has to be verified and everything is a part of the blockchain, the Merkle root or Merkle tree. So I wonder if I can do something like I did with the script visualization, but for the entire blockchain with these OP codes. But then the question is, yeah, I think that's gonna be the challenge of this stuff that I'm trying to do, is trying to think about the logic of how I'm gonna capture certain things. So basically filter this stuff based on certain patterns. And also, I remember another thing that I had problems with is connecting this with the names of companies, because obviously you have the address only and this information. Not this information, but this information. And is not clear from where it's coming from, what company it is. So if you have a contract from Uniswap and another contract from another place, how do you know which one is which? But I think if I just create something based on the wallets and patterns, then it doesn't matter, because you can always use Etherscan later to get specific addresses. And I think that's the vision that I have, is creating something like that allows to filter based on certain patterns and then going from there, I think. And let me go back. What? Is either my internet or... So I'm gonna have to search again. Somewhere else. I think I'm gonna close this documentation. Probably find it on the repo. Yeah, I can find the documentation here probably. Yeah, so I'm gonna close this. So how can I find this? Let me see if the third one works. It's gonna be... It's unfortunate if I can't read the rest. Maybe I should see the attacks as well, instead of reading this one again. Or I'll read this at another time. One of the major dangers of calling external contracts is that they can take over the control flow and make changes to your data that the calling function wasn't expecting. This class of bugs can take many forms, and both of the major bugs that led to the DAO's collapse were bugs of this sort. Entrancy on a single function. I think we'll close this one as well. I'm debating whether or not I should fork this on my stuff. I might not. But what's the name of this? Solidity inline assembly. Not sure if I'm ever gonna look at this, but doesn't hurt to have it here. Oh, it uses C++. Interesting. Yeah, it makes sense. A lot of things are similar from what I remember. Solidity in C++. And I remember someone talking about this. I think, I'm not sure if it was Vitalik or someone like that they used C++, Python, and JavaScript, the principles to create Solidity. I'm gonna close this, close this. The first version of this bug, to be noticed, involved functions that could be called repeatedly before the first invocation of the function was finished. This may cause the different invocations of the function to interact in destructive ways. So there is a mapping of balances, then withdraw balance. Amount withdraw is equal to the number of the account that is withdrawing. Go success, X message, the sender, the call, dot value. At this point, the caller's code is executed and call withdraw balance again. And can call withdraw balance again. Since the user's balance is not set to 0 until the very end of the function, the second and later invocations will still succeed and will withdraw the balance over and over again. A DAO is a decentralized autonomous organization. Its goal is to codify the rules and decision-making apparatus of an organization, eliminating the need for documents and people in governing, creating a structure with decentralized control. In the example given, the best way to prevent this attack is to make sure you don't call an external function until you've done all the internal work you need to do. So the problem is that it's calling the function before updating the state here. And that's why you use the modifier of known reentrant to prevent these forms of attack. And search the sender, the call value, amount withdraw. I don't understand this though really well. What is it calling? Because it's using on the message.sender, but it doesn't make a lot of sense to me. This example given, the best way to prevent this attack, to make sure you don't call the external function before. Okay. So it updates first. If you had another function which called withdraw balance, it could be potentially subject to the same attack. So we must treat any function which calls an untrusted contract as itself untrusted. See below for further discussion of potential solutions. Cross-function reentrancy. An attacker may also be able to do a similar attack using two different functions that share the same state. So if the balance is bigger than amount, true plus amount, so increases from the person that is sending and decreases from the person that is sending, increases from the receiving. And this is the same as the other one. In this case, the attacker calls transfer when their code is executed on the external call in withdraw balance. Since their balance has not yet been set to 0, they are able to transfer the tokens even though they already received the withdraw. This vulnerability was also used in the DAO attack. The same solutions will work with the same caveats. Also note that in this example, both functions were part of the same contract. However, the same bug can occur across multiple contracts, if those contracts share state. Pitfalls in reentrancy solutions. Since reentrancy can occur across multiple functions and even multiple contracts, any solution aimed at preventing reentrancy with a single function will not be sufficient. Instead, we have recommended finishing all internal work, i.e. state changes, first and only then calling the external function. This rule, if followed carefully, will allow you to avoid vulnerabilities due to reentrancy. However, you need to not only avoid calling external functions too soon, but also avoid calling functions which can call external functions. For example, the following is insecure. I guess the issue is that I don't understand these calls here really well. but I think I get the points of the way that the attack works. I just don't understand the details really well. Even though I don't think I'm gonna read this one. Oracle manipulation. Protocols sometimes require additional information from outside the realm of the blockchain to function correctly. Such off-chain information is provided by oracles, which often are smart contracts themselves. Vulnerability arises when protocols relying on oracles automatically execute actions even though the oracle provided data feed is incorrect. An oracle with deprecated or even malicious content can have disastrous effects on all processes connected to the data feed. In practice, manipulated data feeds can cause significant damage, from unwarranted liquidations to malicious arbitrage trades. The following sections provide examples illustrating common vulnerabilities and malfunctions involving oracles. I feel like this is quite intuitive though. Like, it's just the first thing that you think about. If you're gonna do something that relies on an oracle, then you're depending on how correct the oracle is gonna be. Spot price manipulation. A classic vulnerability comes from the world of on-chain price oracles, trusting the spot price of a decentralized exchange. The scenario is simple. A smart contract needs to determine the price of an asset, e.g. when a user deposits ETH into its system. To achieve this price discovery, the protocol consults its respective Uniswap pool as a source. Exploiting this behavior, an attacker can take out a flash loan to drain one side of the Uniswap pool. Yeah, that's why it's not obvious. I thought that because if you think from just the description, it's quite obvious, but the exploitation is not, because you can manipulate and then people didn't think about that. Due to the lack of data source diversity, the protocol's internal price is directly manipulated, e.g. to 100 times the original value. The attacker can now perform an action to capture this additional value. For example, an arbitrage trade on top of the newly created price difference or an advantageous position in the system can be gained. The problems are twofold. The user of a single price feed source smart contract allows for easy on-chain manipulation using flash loans. Despite a notable anomaly, the smart contracts consuming the price information continue to operate on the manipulated data. A more concrete example is provided by the Visor hack. The following code shows that on deposit, the price feed is fetched directly from Uniswap. Here, current tick directly fetches the current price tick from a Uniswap pool. As this price data is fetched from an on-chain dependency and the price data is determined in the current transaction context, this spot price can be manipulated in the same transaction. An attacker can take out a flash loan on the incoming asset A and on the relevant Uniswap pool. Swap asset A for asset B with a large volume. This trade will increase the price of asset B, increase demand, and reduce the cost of asset A, increase supply. When asset B is deposited into the above function, its price is still pumped up by the flash loan. Consequently, asset B gives the attacker an over-proportional amount of shares. These shares can be withdrawn, giving the attacker equal parts of asset A and asset B from the pool. Repeating this process will drain the vulnerable pool of all funds. With the money gained from the withdrawal of their shares, the attacker can repay the flash loan. Under no circumstances should a decentralized exchange's spot price be used directly for price discovery. Secure price calculation can be performed, e.g. by using time-weighted average prices across longer time intervals, assuming sufficient liquidity. This severely increases the cost of a price manipulation attack, making it unfeasible. An example for facilitating secure price discovery is the Uniswap v3 Oracle library docs. Off-chain infrastructure. By definition, a data feed transporting off-chain information into a smart contract requires traditional software to run. From the sensor hardware or manual entry to authenticated APIs submitting data on-chain. It's not uncommon for a plethora of software to be involved. Depending on the concrete implementation, attacks on access control, cryptography implementation, transport, and database security, among others, can be performed. As a result, software providing Oracle services must be hardened and adhere to security best practices, such as the OWASP secure coding practices. Especially oracles which don't offer a community-driven dispute phase must be hardened, as their compromise will directly affect dependent applications. I'm not gonna read this other stuff. Data source, data feeders. Their publications provide a great read on design principles, attacks, and mitigations. An excellent example of an off-chain component malfunction affecting on-chain Oracle data feeds is the syntax this incident. Syntactics aggregates multiple related price feeds to accurately price their derivatives and surfaces the aggregate through a smart contract on-chain, with a value erroneously reported 1,000 times higher than the original. The price of the Korean one was reported significantly higher, even though the aggregation. An arbitrage bot used this effect, which promptly earned it a profit of over 1B USD. While on-chain aggregation and price reporting worked correctly, an off-chain component failure resulted in the incident. Centralized oracles and trusts. Projects can also choose to implement a centralized oracle, such as smart contracts update method can e.g. be protected by an only owner modifier and require users to trust it in the correct and timely submission of data. Depending on the size and the structure of the system, this centralized trust can lead to the authorized user getting incentivized to submit malicious data and abuse their position of power. Additionally, such centralized systems can have an inherent risk due to compromised private keys. Decentralized Oracle security. Decentralized oracles aim to diversify the group of data collectors to a point where disrupting a quorum of participants becomes unfeasible for an attacker. In the decentralized scenario, further security considerations stem from how participants are incentivized, what sort of misbehavior if left unpunished. Participants providing valid data to the Oracle system are economically rewarded. Aiming to maximize the profit, the participants are incentivized to provide the cheapest version of their service possible. Freeloading. Freeloading attacks are the simple form to save work and maximize profit. A node can leverage another Oracle or off-chain component, such as an API, and simply copy the values without validation. For example, an Oracle providing weather data might expect data providers to measure temperature and wind speed in a specific location. Nodes are, however, incentivized to use a publicly available weather data API and simply surface their data to the system. Besides the apparent data source centralization issue, freeloading attacks at scale can also severely affect the data's correctness. This effect is most visible when sampling rates vary, e.g. the on-chain Oracle expects a sampling rate of 10 minutes, while freeloading nodes provide data from an API that's updated once every hour. Freeloading decentralized Oracle data marketplaces can amplify a price raised to the bottom, as freeloading only requires a simple lookup. At the same time, proper data provisioning might involve a more significant computational overhead, with less competition in cheaper price ranges. A few freeloading nodes could even be able to take over a data feed. Freeloading attacks can be easily prevented for more complex data feeds by implementing a commit review scheme. This security measure will prevent Oracle systems participating from peeking into each other's data. For simpler data provisioning, consistency checks punishing nodes that obviously copy data from well-known public services can be implemented. Data collectors contributing to the centralization of the overall service will be disincentivized. Mirroring attacks are a flavor of SIBO attacks and can go hand in hand with freeloading. Similarly, misbehaving nodes aim to save work by reading from a centralized data source. Optionally, with a reduced sampling rate, a single node reading from the decentralized data source then replicates its values across other participants who mirror that data. With a single data read, the reward for providing the information is multiplied by the number of participants. As the number of mirroring participants grows, this increased weight on a single data point can significantly deteriorate error correction mechanisms. A similar outcome to a mirror attack can happen accidentally when a large uninformed part of a community relies on a single data source. A committee review scheme is ineffective to mitigate purposeful mirroring attacks as it does not consider private data transfers between Sybil nodes. Due to the lack of transparency in serial communication, mirroring attacks can be very hard to detect in practice. Solutions. Currently, the easiest ways to solve the Oracle problems are decentralized oracles such as Chainlink. It's the largest decentralized oracle provider, and the Chainlink network can be leveraged to bring decentralized data on-chain. Teller is an oracle that provides censorship-resistant data, secured by economic incentives, ensuring that data can be provided by anyone anytime and checked by everyone. Witnat leverages state-of-the-art cryptography and economic incentives to provide smart contracts with off-chain data. Using a median of multiple oracles provides heightened security since it's harder and more expensive to attack various oracles. It also ensures that a smart contract gets the data it needs even if the one oracle or API call fails. Another standard solution is to use a time-weighted average price feed so that price is averaged out of experts and multiple sources. Not only does this prevent oracle manipulation, but it also reduces the chance you can be front-run, as an order executed right before cannot have as drastic of an impact on the price. This condition does not apply for low liquidity assets, which are generally cheaper to manipulate, even for a prolonged time. Uniswap V2 provides a sliding window example. I think I'm gonna watch the video now, because I'm already tired of reading. Watch the rest of the video. And I'm gonna go grab some water as well. We'll be right back. I'm probably gonna start, after I watch these 2 videos, I'm gonna start doing this stuff here.
Second case, it goes over the limit. If that happens, then all the execution gets reverted. And the reason why that has to be done is because if execution could stop halfway through, then you might be able to sort of perform weird attacks on contracts where you try to like set the execution to expire just at the time when like one half of the changes gets made, but the other half doesn't get made. And we kind of prefer developers to be able to just not worry about that. And so all the execution gets reverted, but the transaction still has to pay for the gas anyway. So don't run out of gas. There's also, gas isn't just a sort of simple one computational step, one gas thing. There are some operations, for example, operations that increase the amount of storage that every node has to store, and those operations take up a very, very large amount of gas. So the gas system is also this sort of fairly intricate set of incentives that are designed in order to encourage basically using the resources of the Ethereum system responsibly. So gas limit is sort of the counterpart to the block size limit in Bitcoin. How is the gas limit set? Fairly simple voting mechanism right now. If you mine a block, then you can upvote or downvote the gas limit by a maximum factor of 1/1024. There is a default strategy that we currently sort of instruct all the clients to follow in the source code, which is you have a minimum of 3141592, and if the usage starts bubbling up and hitting close to the gas limit, then we target 150% of the long-term exponential moving average of the gas usage. So basically sort of target it so that if it does get filled up, the gas limit is going to be sort of just a bit higher than what blocks normally contain. So there are alternate strategies that we're exploring. So one of them is, for example, target a particular on-go rate. So what on-goals are, I'll explain a bit later, but the general concept is that the more the blockchain gets plugged up, then basically the more blocks and the slower blocks propagate, and so the more blocks kind of get lost and don't end up being in the main chain. And as it turns out, thanks to a feature of the Ethereum protocol, you can actually calculate how much this is happening, and so you can kind of target a particular amount to which it's happening. And you can say, if we're seeing more than, let's say, 20% waste from blocks being just falling off the network, then the gas limit should go down. So there are other strategies that we're considering. So transactions contain basically 7 sets of values. Number one, nonce. So what a nonce does is basically every transaction has to have a unique incrementing nonce. So the first transaction you send from an account has to have a nonce of 0. Second transaction you send has to have a nonce of 1. Third has to have a nonce of 2, and so forth. And the reason this is done is to prevent replay attacks. So if Alice sends 10 ether to Bob, you don't want Bob to take that transaction and reinsert it into the blockchain 10 times to give himself another 100 ether. Nonce is fixed that. Gas price, the amount of ether per unit gas, already covered that. Start gas, same thing. 2, the address of the account that you're sending the transaction to, or the contract you're calling. Value, the amount of ether that you're sending. Data is just a field of data. The transaction sender can fill the data field with whatever he wants. It's just an array of bytes, no limits on length. But the more data a transaction includes, there is actually a fee for that in gas. So basically, you have to pay an extra 68 gas for every byte of transaction data that you include. VRS, there are values in elliptic curve signature. So if you're familiar with cryptography, you've probably seen the RDS. The V value is basically an extra flag needed to do public key recovery. So basically, instead of checking the signature against the public key, you actually derive the public key from the signature. So there's this concept called of receipts. So receipts are objects that kind of get hashed into the Ethereum blockchain, and every transaction has a corresponding receipt. So these receipts have a few pieces of data. One of them is an intermediate state root, which once again, I'll describe the mechanism later, but it's a kind of hash that represents the entire state after the transaction gets executed. Number 2, cumulative gas use. So the total amount of gas used in that particular block, including that transaction. So those first two things are kind of needed to do the sort of step-by-step accounting that actually makes it possible to kind of check the validity of individual transactions very easily. And the third thing is logs. So logs are this special feature in Ethereum that it's kind of a different kind of storage. So in general, when you set variables, that gets set in account storage, and that can be read or written by contracts. Logs are basically append only. So if you have a transaction in one particular block and it creates some logs, those logs get hashed into that particular block, but they're not visible. They cannot be accessed by contracts, and they appear just in that block. They're not in any kind of persistent state. So nodes, if they want to, for example, they can just not store logs and they can prune them. So logs are also 10 times cheaper in terms of gas consumption and storage. And the purpose of logs is to allow sort of efficient light client access to event records. So one example of where you want to use a log is, if you go back to the DNS example, you might want to add a single line to create a log in the register method and in, let's say, the set IP method. And the reason why you want to do that is basically in order to allow light clients to very quickly scan through all the logs and sort of see all the instances at which the domain's not registered, IP address got changed, and so forth. So there's lots of applications that want to be able to sort of have a history of things that happen, and logs are a convenient way of supporting that. So logs have a data field, and they have up to 4 topics, and there is a protocol that uses Bloom filters to make it very easy for light clients to kind of search through logs. So basically, if you create a log that has a particular topic, then you can very easily search through the entire blockchain and sort of identify all of the logs that match that particular topic. So Ethereum virtual machine. So once again, as I mentioned, it's this sort of combination of stack-based architectures, traditional virtual machines. So inside of the virtual machine, you have the stack, basically 32 byte fields up to a maximum of 1024 of them. Memory, it's an infinitely expanding byte array, but the more you expand the byte array, the more gas you have to pay. So most of the limits in Ethereum, they aren't sort of static or economic, and that's just a standard thing you're going to see again and again. Storage, permanent contract storage, you can read and write to it. Environment variables. So for example, the virtual machine can access the block number, the time, the mining difficulty, previous block hash, and a whole bunch of other data.
I think I'll go back and forth doing this and watching the videos. And I think I'm not gonna do the speedrun actually. Unless I think I'm gonna try to do this one first. And if I think it's too advanced, because this is the stuff that I'm interested in, that caught my attention when he talked about. So if I think this is true, if I start doing it, I think it's too advanced, then I can do the speedrun, the Ethereum stuff. But the Ethereum speedrun doesn't seem that interesting to me. Mostly because I think I've seen a lot of this stuff already. And it's just more... It's still good, actually, to do it, but I wanna do the stuff that I'm interested on first. Otherwise, I'm gonna rush through this and not really... it's not gonna be good.
So one possible use case of that is, let's say if you have some kind of financial derivative that can only be processed or called struck or whatever after some particular time, then you can say in the contract you can check the current block timestamp against some particular limit that you set. logs, so the virtual machine can create these logs, and there's an opcode by which the virtual machine can itself call other contracts. So this is basically the environment within which this contract code gets executed. Now, you don't have to write in virtual machine bytecode yourself. There's high-level languages. And one of these high-level languages is called Serpent. So this is one of them. There's also one called Solidity, which is being used much more right now. There's one called LLL, which is kind of much more low level. If you want to like really go into low-level code and be as efficient as possible, you might want to use LLL. Although, in my own opinion, you should probably consider Serpent as well, because Serpent lets you go as low level as LLL does, and it has high-level features as well. So basically you write code in these languages, then you have compilers, and you compile the contracts into bytecode, and you can publish the bytecode in a transaction going to the blockchain. The API. So when you send a transaction, let's say that I want to call the register method of that particular DNS contract that I keep on using as an example. Function calls get compiled into transaction data. So in this case, the function call the way that it gets encoded is the first 4 bytes are function ID, the next 32 bytes are the first argument. So this was the domain that I wanted to change the IP address of, and the second argument is another 32 bytes, which is the IP address that you want to set it to. So every time you call a function of a contract in Ethereum, it actually gets compiled into a transaction, which is encoded in using this algorithm, which in simple cases works like this, just 4 bytes, 32 bytes, keep on going with 32 bytes. But there are some special cases involving sort of variable length lists and so forth. Everything in Ethereum relies on this one serialization algorithm called RLP, recursive length prefix encoding. So it's very simple. So basically, it's recursive length prefix encoding. So you take the thing. So in this case, if you take the word dog and you just hex encode it, you get 646F67. And before it, you prefix it with a length. So in this case, the length is 3, and you can see a 3 here. Over here, it's an empty string, and so you have a length of 0. Over here, this is a list, and so it still has a length of 0, but it has a different sort of start flag because it's meant to be a list and not a string. This is for people who are set theory geeks, this is a set theoretic representation of the number 2. It gets compiled to this, or encoded to this, rather. If you have a string, then it gets compiled it gets serialized into this. So there are like 5 implementations of this. There is a much more detailed description on the wiki, but basically this algorithm is used for blocks, transactions, network protocol, literally sort of everything in Ethereum land. Ethereum also has a cool new mining algorithm. So the goal of this, this is called ETH hash. So the purpose of this is to be GPU friendly and ASIC hard. So to target GPUs as much as possible, and basically prevent the problem in Bitcoin where you have these sort of specialized miners with extremely large mining farms taking up huge percentages of the network. So the algorithm uses memory hardness to accomplish this goal. So basically, instead of traditional proof of work algorithms like Bitcoin, where the bottleneck is always how much computation you can do, here the bottleneck is memory access. And the theory behind this is that that memory is something which is highly optimized and which people spend billions of dollars optimizing in existing computers already. And so the opportunity to make further optimizations is theoretically smaller than it is for computation. So the way that it does this is by using this sort of clever multi-level DAG construction. So basically the idea is that you start off with a seed, then from the seed you use this memory hard function, create a cache, then from the cache you create a data set. And the data set can be created in parallel, so each individual piece of the data set actually gets created by hashing together 256 parents that come from the cache. And if you want to just actually run the algorithm once, then what you need to do is you take the data that you're mining on, turn that into a seed, then you grab a random 64 nodes from the pieces of the data set, and you get your result. So what's the point of this? The point of this is that mining with this algorithm actually is memory hard, because if you want to mine, and if you want to mine at any reasonable speed at all, then you basically have to pre-generate this entire 1 GB data set so that every time you pick a different nonce, you can just sort of sample from it, and that happens fairly quickly. If you just want to verify blocks, then you don't actually need the gigabyte. All you need is a cache. And the reason why is basically that when you get to this stage, you don't need to create this entire thing. You just figure out what 64 indices you want. Then from each of those 64 indices, you just compute it from the cache. Now, this does require you to make 16,384 hash calculations, or as it turns out, that's actually not that bad if you're only doing it once. So because verification only needs to happen once, this kind of low memory, slow verification process actually works. But if you want to mine, then you need to do it with a lot of speed, and so you need to have the gigabyte. So this is kind of the basic principle behind sort of why mining was designed in the particular way that it was in Ethereum. So uncles. So in general, Bitcoin has a 10-minute block time, Ethereum has a 17-second block time. Why is the block time not something even shorter, like 1 second? The problem with fast block times is basically stale rates due to network latency. So if the block time is extremely long, like 10 minutes, you can think of network latency as being negligible by comparison. You can think of it as basically being instant. And so you basically don't have problems. Once you start pushing block times down, then your problem is that you have this risk that, let's say over here you have one block, 2059, then at some point someone creates another block, 2060. That block takes time to propagate through the network. And so someone else might actually make another block before hearing about this block. And so you have 2 blocks, both on top of the same block, 2059, and they're kind of both competing with each other. So this is called a fork. And the problem is that one of the blocks has to eventually win, and the block that doesn't win just kind of gets discarded. And the person who mined it doesn't get a reward. So this leads to centralization risks. So basically, the issue is that the more powerful you are as a miner, the better you are at getting high network connectivity. And if you created the last block, then you actually don't have this risk because you can just immediately start making the next block. So because the more these network connectivity issues become important, the more problematic these centralization issues become. And so you have this effect where large miners end up being more effective than smaller miners. So our solution is this mechanism of uncles, which is basically that if this happens, then sure, one of these blocks is going to win, but whichever block loses, it can kind of get re-included in the blockchain, and it still receives most of the reward. So the point of this is it basically cuts the centralization incentives by about 85%, and it kind of allows the Ethereum blockchain to continue to be relatively safe under somewhat harsher circumstances, both in terms of fast block time and in terms of high transaction load. Merkle trees. So how many people have seen the Economist cover from Blythe Master saying it's all about the blockchain? Well, my opinion is it's all about the Merkle tree. So, and particularly unlike Blythe Master's dogs, I like Doge's more. So the point of Merkle trees is that they're this construction that allows for compact, efficiently verifiable proofs that a particular transaction was included in a particular block. So the general principle is that, this actually exists in Bitcoin. If, let's say, every block has a few hundred transactions, then if you want to verify that one particular transaction was included in a block, then you don't have to download the entire block. All you need to do instead is you can kind of download just one sort of branch of this tree. And the tree is this kind of hash tree where every single sort of node in the tree is actually the hash of the two nodes below it. And so what you need to do is just download this kind of branch, just download the specific part of the tree that's going down to your particular transaction. And you check the hashes that are just going up the branch. You don't check all the hashes, just the hashes that are relevant to your particular branch. And if all of those hashes check out fine, then you know that your transaction, that particular transaction actually is in that particular tree, and so actually is in that particular block. So the reason why this mechanism exists is basically for light clients. So what a light client basically is a client that accesses a blockchain without processing every single block, without downloading every single transaction. Why do you want this? Well, it's pretty obvious. The Bitcoin blockchain right now is 30 gigabytes, and about a megabyte gets downloaded every 10 minutes. It might be good enough for a high-powered laptop. It's probably not good enough for this, and it's probably, and 30 gigabytes is probably too much for the devices that Solidity is going to be creating. So instead, you use these sort of clever tree protocols in order to allow these devices to only verify the absolute minimum of information that they have to that's relevant to their particular transactions. So in Ethereum, the Merkle tree mechanism is actually quite a lot more intricate than it is in Bitcoin. So the idea with Ethereum is that it's not just transactions that get stuck into Merkle trees, it's also the state. So if you hear about this concept of a state root, what that basically is this root hash, and from this root hash you have another tree, and this tree goes down, contains hashes of hashes of hashes of hashes of data representing the state of basically every single account in Ethereum. So you have these account objects somewhere at the bottom of the tree. You have nonce, balance, code hash, and storage is yet another tree. So the point here is that if one of these light clients, whether it's my phone or a Solidity device or whatever else, wants to know what the status of one particular contract is, it doesn't have to process the entire blockchain. It doesn't have to trust anyone. All that it needs to do is just ask for a Merkle proof, ask for this sort of branch of the tree, and verify just that one particular branch. So this is basically the sort of concept of the Ethereum light client. Zolt for Fulfoldy is actually going to be presenting quite a bit more about this, I believe, after lunch today. So every block header actually contains 3 trees: transactions, state, and receipts. So transactions are transactions. We know what those are. The state is the entire state of every account, balance, storage, all the sort of static information that you need to know. And receipts are, they consist of this sort of extra auditing information, and they have all the logs. So if your light client wants to know what particular logs are, let's say, associated with a particular topic, then the light client is going to ask for Merkle proofs of logs. So future directions, we talked quite a bit about this on Monday, but the general principles, the general categories are: number 1, proof of stake protocol, or it's going to be sort of risks. Virtual machine.
Yeah, so I also think I'm gonna watch videos about how Polygon is integrated to Ethereum and layer 2, maybe in-depth explanation of layer 2s or something like that. And the way that I usually like to learn things is first by watching videos. I think videos usually are more superficial and easier stuff because most people make videos to get views and engagement, and usually most people are the surface level of things, just the nature of how things work. And then to get more in depth, probably read articles and books and papers, that kind of stuff. So I think I'm gonna start by watching these videos about layer 2s and try to understand more better, and then search for articles as well.
Yeah, now we finish with the white paper, the Italian white paper, and let's move on to the yellow paper, which is going to be about the implementation. So the yellow paper will have much more details than the white paper, and it's also much longer. By taking a quick look, it has nearly 40 pages, and it's a formal specification of Ethereum.
So what is Polygon?
We are not going to read line by line. I mean, I'm not going to read out line by line like the white paper, because that would take way too much work. And actually, I think that we can safely skip over quite a lot of content, since our goal is not to implement for Ethereum client. So with that being said, let's get started. Introduction. Okay, what's about introduction? I think after reading the white paper, where we can skip over the introduction and go to the blockchain paradigm. So what it says here is that they define formally the state as being sigma t, and that the transition between one state and to the next one is through the Ethereum state function, which this character, I don't know what's the name of this character. And that it's the only parameters are the current state and transaction. So I look up that character, and I think it's gamma. And then transactions are put into blocks, and blocks are chained together using a hash, and therefore they form a journal. So a journal is in computer science is a set of transactions that have to be executed one after another, and it records the history. So sometimes it's called a log. They also mentioned that the state is not including in the block because it would be way too big, but the state is implied. I mean, you have to maintain the state, and there's a official canonical representation of the state that is put into the block. Then you have the idea of mining. So mining is putting some work into finding a particular value that makes the block acceptable. So here it is about hashing the block header and getting a value, output value, which interpreted as an integer would be enough to say that this is a valid block. Then there's this formula about how you represent this. So B is the block. B is the block. Let me see. Yeah, B is the block, and you apply. So you apply this particular sigma.
This talk is about the
pi function on the block, and the block is something, but mainly the block is a bunch of transactions, and that sigma function is the application of the gamma function, which changes the state incrementally. So from t0 to using t0, you start from little sigma 0 to sigma 1, and then you apply t1, you get sigma 2, and so on and so forth. So you have to apply this gamma function for each transaction in turns. And finally,
I don't like this that much, to be honest. I'm not gonna watch it. I'm just gonna watch this one and then the other one. I'm gonna watch a little bit of this, and then I'm gonna start this one.
Previously Matic all about, how will it help with scaling Ethereum? Why does it claim to be Ethereum's Internet of Blockchains? And why is it sometimes compared to Polkadot and Cosmos? You'll find answers to these questions in this video. Before we begin, if you want to learn more about decentralized finance and the technology behind it, make sure you subscribe to my channel, hit the bell icon, and enable all notifications. You can also consider joining us on Patreon and learning even more about DeFi. And one more thing before we start, Finematics is now participating in round 9 of Bitcoin grants based on the quadratic funding mechanism, where even the smallest contribution matters. If you'd like to show your extra support for the channel, check the link in the description box below. Now let's see how Polygon came into existence. Before the rebranding to Polygon, the project was known as Matic, or Matic Network. Matic started in 2017 by 3 founders, who were active participants in the cryptocurrency community in India, and decided to band together and tackle Ethereum's scaling problems. The team worked on 2 main solutions, Plasma Chains, and Layer 2 scaling solution based on Matic's implementation of Plasma, and the POS chain, a proof-of-stake Ethereum sidechain. The token behind Matic Network, Matic, was distributed through the Binance Launchpad's initial exchange offering in April 2019, and the team was able to raise $5.6 million. After over 2.5 years of work, the Matic Network mainnet went live in mid-2020 and quickly started attracting more and more attention. This was supercharged by the increasing gas fees on Ethereum that showed an urgent need for finding robust scaling solutions. At the beginning of 2021, the Matic team decided to expand the scope of their project and rebranded themselves to Polygon. Polygon aims at creating a more generalized scaling solution. When it comes to scaling, there are 2 main ways of doing it: Layer 2 scaling and sidechains. Layer 2 scaling relies on the security of the main layer, the Ethereum blockchain. Plasma, optimistic rollups, and ZK rollups are the most popular options. Sidechains rely on their own security models, usually by having a separate consensus mechanism. Matic POS chain, or XDAI, are good examples here. If you're interested in learning more about these different scaling solutions, you can check out this video here. Instead of providing 1 or 2 scaling solutions, Polygon aims at creating an ecosystem that makes it easy to connect multiple different scaling solutions, everything from sidechains with different consensus mechanisms to Layer 2 options, such as Plasma, optimistic rollups, and ZK rollups. We can think about the existing Matic scaling solutions, the POS and the Plasma chains, basically becoming one of many scaling options available in the whole Polygon ecosystem. Polygon also provides a framework that makes it easy for new projects to quickly build their own highly customizable scaling solutions if they decide this is the path they want to choose. Now let's have a closer look at the technology behind Polygon to understand the project a bit better. Polygon supports 2 major types of Ethereum-compatible blockchain networks: standalone networks and secured chains, networks that leverage a security-as-a-service model. Standalone chains rely on their own security. For example, they can have their own consensus models, such as proof-of-stake or delegated proof-of-stake. These kind of networks are fully sovereign, which presents them with the highest level of independence and flexibility, but it makes it more difficult for them to establish a reliable security model. For example, POS requires a high number of reliable validators. This kind of model is usually suitable for enterprise blockchains and already established projects with strong communities. Secured chains utilize the security as a service model. This can be either provided directly by Ethereum, for example, via fraud proofs used by Plasma, or by a pool of professional validators. These validators are run in the Polygon ecosystem, and they can be shared by multiple projects, a concept similar to Polkadot's shared security model. Secured chains offer the highest level of security but sacrifice independence and flexibility. This model is usually preferred by startups and security-focused projects. As we've probably noticed, the distinction between standalone chains and secured chains is even more generic than the usual split between sidechains and layer 2 solutions that we described earlier. This allows Polygon to accommodate pretty much all possible scaling solutions. Now, as we know what kind of solutions are supported by Polygon, let's dive a bit deeper into the architecture. Polygon architecture consists of 4 abstract and composable layers. The Ethereum layer. Polygon chains can use Ethereum as their base layer and leverage Ethereum's high security. This layer is implemented as a set of smart contracts on Ethereum and can be used for things like finality and checkpointing, staking, dispute resolution, and messaging between Ethereum and Polygon chains. This layer is optional as Polygon-based chains are not obligated to use it. The next one is the security layer. This is another non-mandatory layer that can provide a validator as a service function. This function allows Polygon chains to make use of a set of validators that can periodically check the validity of any Polygon chain in return for a fee. This layer is usually implemented as a meta blockchain that runs in parallel to Ethereum and is responsible for things like validator management, registering, deregistering, rewards, shuffling, and Polygon chain validation. The security layer is fully abstract and can have multiple implementations with different characteristics. This layer can also be implemented directly on Ethereum and leverage Ethereum's miners as validators. The next layer is the Polygon networks layer. This is the first mandatory layer in the Polygon architecture. This layer consists of sovereign blockchain networks where each network can maintain the following functions: transaction collation, local consensus, and block protection. Last but not least is the execution layer. This layer is responsible for interpreting and executing transactions that are included in Polygon's chains. It consists of the execution environment and execution logic sublayers. The main takeaway when it comes to Polygon's architecture is that it is deliberately made to be generic and abstract. This allows other applications that are looking to scale to choose the best scaling solution that perfectly fits their needs. As we know, different applications may want to optimize for different things, such as security, transaction speed, transaction cost, or sovereignty, and to excel in one of them usually means making a sacrifice somewhere else. As an example, a DeFi protocol that aims at storing billions of dollars locked in smart contracts probably wants to optimize for security and might be happy with sacrificing sovereignty. A protocol like this would most likely use the Ethereum layer. Another project, let's say an NFT marketplace, may want to optimize for ultra-low transaction costs and would be okay with making a sacrifice by lowering their security from extremely high to high enough. Such a project could skip the Ethereum layer and rely on the security layer with a set of shared validators. Or maybe a blockchain-based game wants to rely on its own consensus mechanism with ultra-fast block time. In this case, they can entirely skip both the Ethereum and the security layer and focus on the Polygon network layer. As we can see, Polygon can provide multiple options, and the teams behind different applications can decide to pick the one that perfectly fits their use cases. It also aims at making it easy to migrate from one scaling solution to another one. This might be needed if the circumstances behind the project change, or if another, better scaling solution becomes available. This architecture also allows for multiple different Polygon-based scaling solutions to communicate with each other. This is super important, as it prevents creating siloed systems. At the moment, the only scaling solution available in the Polygon ecosystem are the Matic POS chain and the Matic Plasma chain solutions. The team is also actively working on adding multiple other options, such as ZK rollups, optimistic rollups, enterprise chains, and other sidechains. Currently, projects launching on Polygon start with the Matic POS and the Matic Plasma chains. Matic Plasma chains is an Ethereum Layer 2 predicate-based Plasma implementation. Plasma, in essence, is a framework for building scalable decentralized applications. Plasma allows for offloading transactions from the main chain into child chains, which enables fast and cheap transactions. One of the drawbacks of Plasma is a long waiting period for users who want to withdraw their funds from Layer 2. Plasma cannot be used to scale general-purpose smart contracts. Matic POS chain is a permissionless sidechain and runs in parallel to the Ethereum chain. The chain is secured by the proof-of-stake consensus mechanism with its own validators. Although Matic POS chain has its own consensus mechanism, it also relies on Ethereum security when it comes to validator staking and checkpoints. Matic POS chain is EVM compatible, which allows Ethereum-based projects to effortlessly migrate their smart contracts. So far, Matic POS chain and Matic Plasma chains were able to onboard over 80 applications, process over 5 million transactions, and secure over $200 million of users' funds. Some of the projects that have either already migrated to Matic POS chain, launched directly on Matic, or are in the process of migrating include QuickSwap, a fork of Uniswap, SushiSwap, Avegochi, Polymarket, Polka Markets, and Superfarm. Besides that, infrastructure projects such as the Graph and Chainlink also decided to expand to Polygon. Recently, Polygon also announced a partnership with a big player in the video gaming industry, Atari. So far, it looks like Matic's rebranding to Polygon and the expansion of the scope of the project was a really good idea. This is mainly because it becomes clearer and clearer that there will be a spectrum of different scaling solutions available in the future. In the new architecture, Polygon can facilitate connections between these different scaling options. It also looks like there is a big focus on both optimistic rollups and ZK rollups, which Polygon can also add to the multitude of available scaling solutions. The main risk here would be if one of these popular scaling technologies gets adopted on its own without integrating with Polygon. But even if this happens, there is a chance that this technology would eventually be integrated into Polygon anyway. It will be interesting to track Polygon's progress when it comes to adding more scaling options and onboarding more and more projects. We'll also have to see how easy it will be to communicate between different scaling solutions with different security guarantees. It's also worth mentioning that Polygon's white paper has direct comparisons to other Layer 1 blockchains, such as Polkadot, Cosmos, and Avalanche, that also focus on the interoperability between different blockchains. In contrast to these projects, Polygon focuses on the Ethereum ecosystem, with the Ethereum chain being the main hub that connects everything. This, of course, has a lot of advantages, such as a strong community of users and developers, a well-known programming language Solidity, and the most popular virtual machine in the cryptocurrency space, EVM. Besides that, Ethereum has a long history of serving as a reliable base chain that handles trillions of dollars in economic activities, something that took time to develop and is hard to be replicated by a completely new blockchain. The power of familiarity with the Ethereum stack cannot be overlooked, as shown by the recent rise of Binance Smart Chain. So what do you think about Polygon? Will this be the ultimate way of scaling Ethereum? Comment down below. And as always, if you enjoyed this video, smash the like button.
Okay, hello and welcome everyone. This is the Ethereum Engineering Group Meetup. Today, David and I are going to talk about the EVM, Solidity, and what Solidity looks like as a program in the EVM and how it uses code, storage, stack, memory, and other things. David, do you want to introduce yourself?
Hi, David Holland Wood from Consensus. I work with Peter in the Pegasus business unit on TMX. All of us are here at TMX are pretty much present, I think. So if you want to speak with any of the others doing this area of work, please either ask questions or introduce yourself to people that you may not know. Peter.
So thank you. So before I start, I'll say that David and I, we brainstormed this talk and we were going to work on it and do about equal parts, but David got super busy. So you won't hear David talking as much as I am, but he still knows a lot about this stuff. So yeah. All right, let's do this. So if I go play there, just a sec, as Google Slides catches up, and so does, let's move that over there and go present on that screen. Sorry, just getting my screens to work. And now what we'll do is we'll share screen and we'll share desktop too. Okay, so you should all now be able to see my slides. Can people see the slides?
Yes.
Right, brilliant, thank you. Okay, so this is a talk on the EVM. And we've put together the talk and we've had a lot of feedback from these people, which has been very much appreciated. We're going to walk through an introduction to the overall topic and then talk about Ethereum transactions and how they relate to it all and walk through slowly but surely. If we get to about 1.5 hours in and we're not finished, what we'll do is we'll reconvene this time next week. So we'll see how we go. So there are some examples in this talk, and they can all be found in the Ethereum Engineering Group Solidity examples. The bytecode output that you'll see was generated using some tools that we've created, and the stack analysis was created using some static code analysis tools that we've created. So when you think of the Solidity language, you've got a file that's something or other .sol, and that's your source file. You put it into the compiler, and normally you get out the ABI in the bin. You can specify parameters to say what you want to get, but those are the two files you normally end up with. And your binary file has your is your output of the actual bytecode, and the ABI is an interface file which tells applications how to interact with the code. So essentially, what functions your code supports and what parameters they take. So it's worth remembering that Solidity is but one EVM language. So for instance, there's a language called Viper, which is in alpha at the moment, and it's compiled with the Viper compiler. All of that said, we've done some recent analysis of all of the deployed contracts on mainnet, and the numbers are indicating that it's well over 90% of the contracts on mainnet were created with various versions of Solidity. And so I'm not going to give you exact numbers because our analysis needs just a little bit of tweaking. So once you've got that binary file and the ABI, you then put it into some sort of Solidity wrapper generator, and that will generate, say, a Java wrapper, which essentially is an interface that you can call from your Java code to call the Solidity code inside of the Ethereum node. If you were using JavaScript, obviously you end up with a JS file, or maybe you can just use the library interact directly. And so once you've got your application code and your wrapper code, you use a library, some sort of Web3 library, and then that talks to your Solidity code via the internet, and your Solidity code will be running inside the EVM, inside an Ethereum client, inside of the Ethereum network. So an Ethereum client is an instance of software running on a node in the network, and a client, given we're in a peer-to-peer network, is both the server and the client. So it's essentially the machine that's operating the Ethereum network. And so, so you've got to think your application is interacting with the Solidity code, that is now bytecode, inside of the EVM. Okay. So I think I've just skipped, So in this talk, we're going to focus on that bytecode in that code.bin. So that's the code that gets executed by the EVM. So in Ethereum, you have transactions. And these are the things that are sent over the wire between the application and the Ethereum node, and also then around the network. And so you've got a nonce, and so that's a value that starts at 0. You've got the gas price, which is how much you're prepared to pay for gas in terms of ether, or in particular we, where we is a unit of 10 to the minus 18 of ether. You've got the gas limit, which is the amount of gas you're prepared to use, the to address, so who you're sending the transaction to, and the value, and the data to be sent to the to address, and the signature. So if you're just transferring money between accounts, then you have it set up like this, where you always specify just 21,000 because that is how much gas you need to use for a base transaction, and the address you're sending the ether to, and the value, and the data is usually empty. But it's actually worthwhile pointing out that the data doesn't have to be empty. It's not mandatory. And so if all you want to do is record a commitment onto the blockchain, you could put some data there, and then you'll have that as part of the overall blockchain. So it's important to remember, though, that it's not going to be part of world state. So it's not going to be part of the state tree, but it will be part of information that gets linked into the overall blockchain, because the summary of all the transactions, so the transaction root, is part of the block header. If you're going to deploy a contract, the to field has to be empty, and that indicates to the Ethereum client that you want to create a contract. And the data field contains the initialization code, so essentially a code fragment, which is going to set up the state of the contract and deploy the contract. If you want to do a function call, then the data field is the parameters. So what function do you want to call, and what are the parameters? And it's really up to the EVM code to process that. So code that conforms to the ABI specification takes a function selector and parameters. However, EVM code does not have to conform to the ABI spec. It could do anything. And as such, that data field is just a blob of data that the EVM code can do stuff with. And there's a link to the ABI spec. So
stack memory storage. So all of the locations you can do stuff with in the EVM. So the EVM, so Ethereum, is a stack-based processor. And what that means is that there aren't registers. You've only got the stack. And so when you have to do an operation, you use stuff from the stack, and then you take input from the stack and you pop that input off, and then you push onto the stack the result. So add is popping off the stack 0 and stack 1 being 7 and 2. It's adding them together and pushing the result 9 onto the stack. And so inside of the EVM, you can access and store information from 6 different places. So there is the stack. So you can push stuff onto the stack and keep it there for a while as temporary storage.
I think I'm gonna start this before I continue. And I think I'm probably gonna leave soon because this headphone is annoying me, to be honest. So I'm gonna watch the videos off stream. Hello Eternal, this level walks you through the very basics of how to play the game. Set up MetaMask, don't have it already, install the MetaMask browser, set up the extensions wallet, use the network selector to point to the RinkBy test network in the top left of the extensions interface. Network selector, so pretty much change to RinkBy, I think. What is this? Okay. So it looks like it's already on the RinkBy. Open the browser's console, open your browser's console tools, developer tools. You should see a few messages from the game. One of them should state your player's address. This will be important during the game. You can always see your player address by entering the following command: player. Keep an eye out for warnings and errors since they could provide important information during gameplay. So I'm gonna change the screen because I'm not sure if I can show stuff. This telling me to go to tools. Fortunately, my thing is on Portuguese, but I think I found it. Oh, it's pretty much telling me to use the inspect. Should see a few messages from the game. Okay, I see. Here. Interesting. See your player address by entering the following command: player. I guess that's why MetaMask was giving me the warning. I'm not sure. Use the console helpers. You can also see your current Ether balance by typing get balance player. Note, expand the promise to see the actual value, even if it reads pending. If you're using Chrome v62, you can use await get balance player for a cleaner console experience. Wait to see what other utility functions you have in the console type help. Okay, wait, get balance player. Interesting. Then help. Version instance, index player, eternal. The eternal contract. Enter the following command in the console. Eternal. I guess I'm gonna make it bigger so it's easier to see. This is the game's main smart contract. You don't need to interact with it directly through the console, as this app will do that for you, but you can if you want to. Playing around with this object now is a great way to learn how to interact with the other smart contracts of the game. Go ahead and expand the internal object to see what's inside. So there's level completed, level instance, ownership, ABI address, all events, constructor, contract, create level instance, methods, create level instance, owner, transfer ownership, renounce ownership. Interact with the API. Ethernote is a truthful contract object that wraps the ethernote.sol contract that has been deployed to the blockchain. Among other things, the contract's API exposes all of the ethernote.sol's public methods, such as owner. Type the following command, for example. Ethernote.owner. I have to await probably. Okay. Yeah. It's because it's asynchronous in the blockchain. You can see who the owner of the internal contract is, which is not you, of course. Get test ether. To play the game, you need test ether. The easiest way to get some test net ether is via this or this faucet. Once you see some ether in your balance, move on to the next step. I think I already have, yeah. I think I'm gonna get more because I might need for the other projects. Damn. I don't know why this is not working. Although that the stuff is really cheap, at least to mint the NFTs, the gas fees were really cheap, so I don't think I'm gonna need it, but it's better to get it because you can only get a fixed amount per day. So if in case I need it, it's better to have more, obviously. Getting a level instance. When playing a level, you don't interact directly with the eternal contract. Instead, you ask it to generate a level instance for you. To do so, click the blue button at the bottom of the page. Go do it now and come back. Oh, this one. Hey, progress with what? I just started this thing here. Apparently it's a game. At the bottom of the page, go do it now and come back. You should be prompted by MetaMask to authorize the transaction. Do so and you should see some messages in the console. Note that this is deploying a new contract in the blockchain and might take a few seconds, so please be patient when requesting new level instances. Okay, so when you click this, you're creating the next level, I think. Inspecting the contract. Just as you did with the eternal contract, you can inspect this contract's API through the console using contract variable. Let's see if I get anything. Okay, so I have to set new instance first. Interact with the contract to complete the level. Look into the levels info methods. Await contracts.info. What? It's not a function. Oh, I have to get the instance first. Oh, you just joined? Is it for that shop? Which shop do you mean? You should have all you... No. The marketplace is the project that I'm doing for our Buildspace. This is something from a library called Open Zeppelin. It's pretty much one of the fundamental libraries of Solidity. Pretty much everyone uses everywhere. They have all the functions for creating NFTs and all the other stuff. And then the other guy recommended to do this. This guy from the Ethereum speedrun hosting. This guy here. And it's pretty much to learn Solidity better. And he said that this is for more advanced people. So after you do the speedrun, the Ethereum speedrun that he did, you should do this one, which is more advanced. but I'm more curious about this one, so I'm gonna do this one directly. And if I can't do it, then I'll go back to this one and try to do it. Yeah, but I'm not sure if I'm gonna. I'll see how it goes, because I have the other project to do it. So the Buildspace project is obviously the priority, but I wanna do this stuff because later on I'm probably gonna see if I can get information from the blockchain, and is better if I know if I'm very good at the low level stuff, I think, to understand what kind of information I can get and what information I can't get, to keep building the marketplace, because I'm gonna put some data analysis into it, which is the main thing that I want to do. But I didn't want to choose that from the beginning because I'm not sure how hard it's gonna be. So I decided to go with the NFT marketplace because I already have the full thing from another project that I did. So worst case scenario, I have something to show for. When you know you have completed the level, submit the contract using the orange button at the bottom of the page. This sends your instance back to the Ethernaut, which will determine if you have completed. Don't forget that you can always look into in the contracts API. Okay. I don't think I... Yeah, so it doesn't look like it's gonna be very expensive to do this stuff. Now I can do await contract probably. Contracts.info. You'll find what you need in info 1. Trying for two, but with hello as a parameter. Contracts.two. Hello. It's really interesting that they decided to do this stuff on the console log. I wonder how they do this. The property info num holds the number of the next info method to call. The property info num holds the number of the next info to call. So I guess I need to call this and then, or maybe just info num. And I don't understand when I can submit this. You should have all you need to complete the level within the contract. When you know you have completed the level, submit the contract using the orange button and the orange. So I guess I need to follow the scenes here until it tells me to click the button. Let's see. I'm gonna try to do this and see if it works. This is also interesting. If you've used Forda, contributed to a Web3 project, or are an active participant in the Web3. What is Forda? Operational monitoring of blockchain activity. I guess I don't lose anything. And it's from Open Zeppelin, so I think you can trust this site. Whatever. I'll check again after I do a bunch of of this, you see. Oh, okay, so I get it now. So I have to follow all the steps until I'm able to unlock the other ones. So it's saying that I should call info num here. The property info num holds the number of the next info method to call. Info latest array prototypes last call. I'm not sure if I understand this. Maybe I should call it as if I was calling a function. Yeah, this is probably some webpack compiled code. So maybe I should call it instead of I guess the question is, how do I access a method? Wait, contracts.info or dot info now. Just try to do like this. Maybe it's 42. Wait. Contract.info. Oh, can't I just see there? The method name is the name of the next method. What the hell does that mean? Oh, it's probably this. The thing is, I can just look at all the possibilities here. But I guess you have to follow one by one. If you know the password, submit it to authenticate. I think it's the number, but I'm not sure. It has to be. I don't know what else it can be. 7112 3949. Yeah, the only problem is I'm gonna spending a lot of fake ether on this stuff. I think it worked. It's weird that it didn't tell me anything about the password here. So the only thing that makes sense to me is should be the number of the method. Just send for the authenticate. Yeah, that doesn't make any sense. Let me see how many I have here. Oh, it's still a lot. What else can I try? Maybe I can just try random ones. Contract dots. Passwords. It's probably the one to call. Turn out 0. I don't understand why I have to call the other ones though. It doesn't make sense. You can always look in the contracts ABI. Did they say how to do that here? I guess you can just get the address and then search on Etherscan. But I'm not sure if that's how I'm supposed to do it. Oh, nice. This level is not translated, or translation is complete. Clear, simple. Congratulations, you have completed the tutorial. Have a look at the solidity code for the contract you just interacted with below. You're now ready to complete all the levels of the game, and as of now, you're on your own. Go to next level. So password, info num. Interesting. Look carefully at the contract's code below. You will beat this level if you claim ownership of the contract, you reduce its balance to 0. Things that might help: how to send Ether when interacting with an ABI, how to send Ether outside of the ABI, converting to and from way Ether units. Interesting. I think this is probably gonna be the reentrancy attack thing, if I have to guess, just based on the name of the stuff. But I have to claim ownership. Oh, so maybe when I create, I'm gonna be owner, or no? Yeah, I wanna create, I'm gonna be the owner. I'm just so just create and call withdraw. It seems so easy. How to send ether when interacting with an ABI. How to send ether outside of the ABI. Converting to and from way ether units. Fallback methods. Let me just try to call the withdraw thing and see what happens. Maybe I need to actually say fallback. Let me see. Also, I have to use the contract. It's probably not this, because otherwise it would be too easy. So I probably need to do something with the ABI. Or send ether when interacting with an ABI. But I'm not sure how I can view the ABI besides looking at the ether scan. Caller is not the owner, so yeah. I'll send ether when interacting with an ABI. Oh, so this is the function here that the exploit is gonna happen. So I probably need to call this function and then have a fallback. To withdraw. I think I'm gonna do this another time, to be honest. I think I'm gonna stop here today. Not sure when I'm gonna come back, because I think I'm gonna work off stream on the NFT marketplace until I have all of the other stuff. And then I'm probably gonna continue to do this thing here and study more the Solidity, the EVM, the yellow paper, and the layer choose in Polygon, so I can extract the data later on. And I think after I have the whole functionality of the NFT marketplace, the same way that it was working on the Silo network, but for other chains now, I'm going to work on changing the nav bar on string probably, and deciding what features I'm gonna put on the nav bar so I can create the new pages later with the other functionality. And I'm also thinking about creating the backend and all the other stuff. But everything is gonna depend on how hard I think it's gonna be. So yeah, not sure when I'm gonna come back, but I'm probably gonna do this next time. So see you then.